Hi, hello everybody. Hi. Very good morning, Andariki. Hi. Hello, how are you all? Please tell me if my audio video are visible. Andariki, okasari cheppandi ra. So, everything clear from my side, sir? Yes, sir, everything is clear. Correct. I'm fine. What about you guys? Hello, Andariki. I hope you are not getting depressed because of your exams. Okay. Sir, chala mandi problems unnai sir life lo. You are talking only about exams, You are not getting the nutrition properly. Ade kada? Yes. All right. So, ఇప్పుడు start చేద్దాం your wave optics chapter, okay? Yes, very good. చూడండి. So, the basic introduction that I want to give to all of you, అందరికి జాగ్రత్తగా వినండి, okay? Wave optics కోసం your waves should be good. Waves అంటే ఏంటిరా? Waves లో especially your interference of waves, okay? Yes, I'm fine, everybody, I'm fine. I'm absolutely fine. Yeah, so చూసుకోండి. Yes, so what are we talking? Wave optics discuss చేయడానికి your prerequisite లేదా your basic knowledge is your waves. Waves లో కూడా you must be very well equipped with your interference of waves రా. Interference అంటే ఏంటి సార్? If you have two equations, y1 is equals to a1 times of sine of omega t, the second equation is y2 equals to a2 times of sine of omega t plus phi. How to add these two equations? It is the third time, all of you, okay? It is the third time that we are discussing this on a board ra. Chudandi. Before this, I discussed in SHM. Dan tarvata, we talked about it in waves, okay? No, not third type. Actually, it is the fourth type. Fourth time I am discussing. Third time, yesterday itself, yesterday and day, your lecture of alternating current. Deentlo, when we were talking about your RC circuit, your LR circuit, we have discussed the same formula. Hi. Hello, everybody. Hi. So, it is the fourth time that I am discussing these things with you. If you are not good with it, you are going to face a great difficulty. Andariki. Hi. Srivani, hi. Srivani. చూసుకోండిరా. So, ఇప్పుడు before starting your wave optics chapter, let us quickly go through this introduction ra. Chuskondi, okay? Before starting itself, endukante I don't want to make the things complicated when the chapter starts actually, okay? Ippudu we are going to discuss the resultant లేదా the addition of two SHM equations ra, okay? Let us try to understand what the equation truly means. Chuskondi. మీ ఫస్ట్ ఈక్వేషన్లో యూ హ్యావ్ ద ఫార్మాట్. వాట్ ఫార్మాట్ సార్? మీ y1 is equals to a1 into sine of omega. ఇప్పుడు చూడండి, y1 అంటే ఏంటిరా? y1 is the displacement of the position that is doing SHM kada. Yes, it is doing up and down, up and down, up and down. Chuskondi, it is doing SHM kada, right? So if it is doing SHM, its position is given, vertical position, y-axis lo its position is given by this equation. Chuskondi ra, idi A1 ante your amplitude, okay? Gurtupettukondi, these important results are A1 ante amplitude. Me second equation lo y2 equals to A2 times of sine of omega t plus some angle phi ra. Em difference unnai cheppandi okasari andariki. What is the difference between these two equations? The first difference is, sir, amplitudes are different. Ide kada? Yes, the amplitude for this is A1 and the amplitude for this is A2. Ide kada? Yes. Amplitudes are different and the amplitudes very unnai. The second difference you have is in the phase angles ra. Chuskondi okasari. This is omega t plus phi and ide ante only omega t. This is the second difference. Rendu differences unnai. You keep it in your mind, okay? What are the similarities ra? The first similarity ardhamaindi. When you add it, chuskondi ra. Malli here also you have two different ways to add it, and there we will follow a separate method for your amplitudes. Hey, is it clear? Correct. Am I buffering all of you? Am I clear? Is it clear? Is it clear? Is it clear? Right. Chudandi. Right. So when we add these two equations, andariki jagrataga vinandi, okay? We have two different things ra. We use another approach for amplitudes and we use another approach for your phase angles. Chuskondi. Important ante ade. Okay? Only two things are important. The first thing, the first approach will be for calculating your amplitude ra. And dan tarvata the second most important thing is the phase. Chuskondi. Ade. Only these two things. Whenever epadaina an SHM equation is given, only observe two things. What are two things, sir? First is the amplitude, second is the phase. Ide kada? Yes. Jagrataga vinandira, all of you. So let us take the same equations. Y1 equals to A1 into sine of omega into t, and at the same time y2 is equals to A2 into sine of omega t plus phi. Chusko. What did I say? What did I say? Whenever the equations are given, andariki, we will see two things. First about their amplitudes and then about the phase angle. Ide kada? Yes. Ippudu amplitude kosam cheptunna chuskondi andariki. So when you talk about the amplitude A net, ide kada? A net ra, we have to add this. The biggest question is, they will not be added directly A1 plus A2. Ledandi ra. It will be added for the following your vector notation. Vector notation ante entira, root of A1 square plus A2 square plus 2A1 A2 into cos phi. Phi ante the same phase difference ra. Ante ippudu I am writing the most important statement. Okkasari chudandi endariki. Your phase leda your phase angle ra. Phase angle ante enti? Phase angle phi decides. Phase angle phi decides the net amplitude. Ante dependence is there andariki chudandi. Ante your amplitude is dependent on the phase angle and similarly your phase angle is dependent on the amplitude. Ade kada? Yes. Decides the net amplitude. This is my statement number 1. Dan tarvata when you talk about the second statement, you simply say your amplitudes, rendu amplitudes, okay? A1 and A2 kuda. Your amplitudes decide the net phase angle. Ante both are dependent on each other. Your amplitude dependent on phase angle and your phase angle depended on your amplitude. Ade kada? Yes. So how to find the amplitude? Chudandi andariki. Ee amplitude calculate cheyadaniki you simply say, sir, A net is equals to root of A1 square plus A2 square plus 2 into A1 into A2 into cos phi. Choose good. This cos phi is the phase difference. Lay the phase angle difference. Whatever it's there. Okay? Correct. And at the same time, when you are calculating about the phase angle, phase angle gurinchi chustu. Understand? So first phase angle is sine of omega t. ఇదే కదా? Yes. And A1 is the amplitude and the phase angle is omega t. రెండు ఈక్వేషన్ చెప్పండి రా. A2 is Y2 is equals to A2 into sine of omega t plus phi. ఇప్పుడు try to understand. Your first angle, మీ first phase angle అంటే omega t. And your second phase angle is omega t plus phi. అదే కదా? Yes. Sine remains sine ra. అంటే when you are talking about net amplitude, this is your formula. This is your formula. అదే కదా? Yes. When you are talking about sine remains sine only. Don't worry. కానీ your phase difference changes. చూసుకోండి. So when you talk about the phase angle phi 1 ra. Phi 1 చెప్పండి ఒక్కసారి. It is omega into t. ఇదే కదా? Yes. This is your first phase angle phi 1. Your second phase angle phi 2 is omega t plus some random value phi ra. చూసుకోండి. ఇదే మీ second phase angle కదా? Yes. But when you add these two, అంటే phi 1 plus phi 2, you don't simply say sir omega t plus omega. Not like this. No. చూసుకోండి. Your phase angle, అంటే your net phase angle will be between these two. అంటే ఏంటిరా? చూసుకోండి. అంటే your phase angle phi net will be between omega t and omega t plus phi. For example, omega t and omega t plus 90 ra. For example, చూసుకోండి. Your first angle is omega t, your second angle is omega t plus 90 degree. Your phase angle may be omega t plus 40 degrees ra. చూసుకోండి. ఇదే ఈ 40 డిగ్రీ ఎక్కడ ఓన్లీ ఒమేగా టీ ఉంటే ఒమేగా టీ ప్లస్ 0 కదా? ఎస్. ఒమేగా టీ ప్లస్ 0, ఒమేగా టీ ప్లస్ 90, ఈ మధ్యంలో వాల్యూస్ అంటే 40 ర్యాండమ్ వాల్యూస్ తీసుకున్నాం. చూసుకోండి. ఇదే కదా? ఎస్. సో దాట్ మీన్స్ యువర్ ఆంప్లిట్యూడ్ ఈజ్ కంప్లీట్లీ డిటర్మైన్డ్ బై యువర్ ఫేజ్ యాంగిల్. చూసుకోండి. దెన్ అట్ ద సేమ్ టైం యువర్ ఫేజ్ యాంగిల్ ఈజ్ ఆల్సో కంప్లీట్లీ డిటర్మైన్డ్ by your amplitudes. చూసుకోండి అందరికి. సో ఇప్పుడు let us take a very general case and let us derive two different equations. Okay, let us say y1 is equals to a1 sine of omega t plus phi 1, and similarly y2 is equals to a2 sine of omega t plus phi 2. మొదటిగా I'm talking about your phase angles రా. చూసుకోండి అందరికి. So you can simply say sir not phase angles, amplitudes. I'm sorry, amplitudes. So beginning lo I'm talking about your amplitudes. A net is equals to, it will add vectorial kada. So it is a1 square plus a2 square plus 2 a1 a2 into cos phi. This is your net amplitude. Ippudu when you talk about the, hey, am I correct? Hey, let us take phi 1 equals to 0 ra. Not there for your case. And when we talk about the phase angles, చూసుకోండి రా. So your y1 plus y2 అంటే a1 sin of omega t plus a2 sin of omega t plus phi. ఇదే కదా? చూసుకోండి. a1 plus a2 gives me a net. I don't have any problem. a net అంటే ఇక్కడ రాశాను కదా? The only problem is what should I write inside sin ra? So you take omega t common. అంటే omega t. It will be omega t only. Plus take a random value alpha ra. చూసుకో. Take some random value alpha. ఎప్పుడు ఈ alpha గురించి మాట్లాడాలంటే you can simply say sir tan of this angle alpha is simply equals to a2 sin phi. చూసుకోండి. a2 sin phi. Start from the right side. It is simply equals to a2 sin phi divided by a1 plus a2 cos phi. చూసుకోండి రా. ఓకే, సో దీస్ ఆర్ ద వెరీ 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 ఇంపార్టెంట్ ఫార్ములాస్ టు బి రిమెంబర్డ్. ఓకే, రైట్, కరెక్ట్. సో లెట్ us take some questions based on this. దాని తర్వాత we will directly be jumping to our question chapter. ఓకే, సో ఫస్ట్ క్వశ్చన్ is two SHMs లేదా two waves, should not say waves, two SHMs. Superposition kuda antaru. Sometimes it's also called as superposition. Don't get confused. Hey, ఇది చాలా important, okay? I would not focus on useless topics. Ante I'm insisting. That means it is important, kada? Yes. If possible, we'll take 2-3 questions, right? Don't worry. Kani, I want all of you to be perfect in it. Chuskondi. Compare. You have first form y1 is equals to 10 into sine of 4t. Ide kada? Yes. Your second equation y2 is equals to 10 times of sine of 4t plus 120 degrees. ఇప్పుడు ఈ రెండు ఈక్వేషన్స్ ని ఒకసారి కంపేర్ చేసుకోండి మీ స్టాండర్డ్ ఈక్వేషన్స్ తోనే. సో యువర్ స్టాండర్డ్ ఈక్వేషన్స్ ఆర్ సంథింగ్ లైక్ దిస్ రా, a1 into sine of omega t and your y2 should be a2 into sine of omega t plus 5. ఇదే కదా? ఎస్. వాల్యూస్ చెప్పండి రా ఒకసారి. యువర్ a1 comes out to be 10. a1 అంటే 10 కదా? ఎస్. సిమిలర్లీ a2 is also 10. రైట్? ఎస్. మీ a2 కూడా it is equals to 10 రా. ఇప్పుడు దిస్ ఎక్స్ట్రా యాంగిల్ 120, ఎక్కడ కూడా దిస్ ఎక్స్ట్రా యాంగిల్ 5 దే ఆర్ సేమ్ కదా? ఎస్. సో యువర్ 5 వాల్యూ కమ్స్ అవుట్ టు బి 120 degrees. చూసుకోండి. ఇఫ్ యూ డోంట్ రిమెంబర్ ద వాల్యూస్ ఆఫ్ సైన్ అండ్ కాస్, యూ గెట్ ఫ్రమ్ హియర్ రా, cos 120 is minus half sine 120 is equals to root 3 by 2. And if you're talking about it, let us say, I don't require this tan value. These are the important results. Choose. Now, we will do two things in two different ways. Ante, first we will talk about your amplitudes. Okasari your amplitude has been calculated ante, you can go for your phase angles. Amplitudes gurinchi cheppandi okasari. Your a net comes out to be root of a1 square plus a2 square plus 2a1 a2 into cos 5. ఇదే కదా? ఎస్. ఇప్పుడు మీ వెక్టర్స్ స్ట్రాంగ్ ఉంటే యూ డోంట్ ఈవెన్ హ్యావ్ టు డూ దిస్ క్యాలిక్యులేషన్స్, డైరెక్ట్ గా కూడా చెప్పొచ్చు. కెన్ యూ టెల్ మీ వాట్ ఈస్ ద రిజల్టెంట్ ఆల్ ఆఫ్ యూ? నో, యూ కాంట్ టెల్. మై వెక్టర్స్ ఆర్ గుడ్ రా, కాబట్టి ఐఎమ్ టెలింగ్ యూ ఇట్స్ 10 ఓన్లీ. ఓకే, డైరెక్ట్ ఆన్సర్ కమ్స్ అప్ టు బి 10. చూసుకోండి. హౌ సార్? డూ ఇట్. Root of a1 square అంటే 10 square అంటే 100 plus a2 square అంటే 10 square అంటే 100 plus 2 into a1 a2 అంటే 100. మళ్ళీ ఒకసారి multiplied by cos 5 అంటే cos 120 minus half. Minus half కదా? Yes. చూసుకోండి. So this comes out to be minus half ra. This 2 and minus half gets cancelled. ఇదే కదా? Yes. So it's 100 plus 100 minus 100. చూసుకోండి. This negative, here is positive. Negative, positive, negative. Negative 100. So ఈ పాజిటివ్ 100 ఇది నెగటివ్ 100 కూడా క్యాన్సల్ రా. రూట్ ఆఫ్ 100 రిమైనింగ్, సో దాట్ కమ్స్ అవుట్ టు బి 10. అంటే యువర్ నెట్ ఆంప్లిట్యూడ్ ఇస్ 10 ఓన్లీ. ఇప్పుడు వాట్ అబౌట్ యువర్ ఫేజ్ యాంగిల్స్? అందరికి చెప్పండి. వాట్ అబౌట్ యువర్ ఫేజ్ యాంగిల్స్? మీ ఫేజ్ యాంగిల్స్ గురించి చెప్పాలంటే యూ క్యాన్ సింప్లీ సే యువర్ ఈక్వేషన్ విల్ బి y net is equals to, చెప్పండి, y net is equals to a net into sine of omega t plus alpha. Formulas గుర్తుపెట్టుకోండి. ఓకే, మళ్ళీ ఐఎమ్ ఇన్సిస్టింగ్ ఆన్ ద ఫార్ములాస్ ఓన్లీ. వెరీ గుడ్, వెరీ గుడ్. సో ఏ నెట్ వాల్యూ ఇప్పుడు క్యాలిక్యులేట్ చేసినాం కదా, 10 multiplied by sine of omega t plus alpha. ఇప్పుడు ఈ ఆల్ఫా గురించి వాల్యూస్ కావాలిరా. ఈ ఆల్ఫాకి వాల్యూ కావాలంటే యూ సింప్లీ సబ్స్టిట్యూట్ ద ఫార్ములా. What is the formula, sir? Tan alpha ki formula. You have a formula for tan alpha. Chuskondi. So your tan alpha is equals to A2 into sin phi divided by A1 plus A2 into cos phi. This is your angle. Yes. A2 value cheppandi ra. A2 A1 10 same ante 10 multiplied by sin phi. Phi ante extra angle ra chuskondi. Me question lo unte extra angle ikkada kuda phi and here is 120 kada. So phi value ante 120 degrees. Sin 120 ra. Sin 120 is root 3 by 2 divided by A1 value. Malli okkasari it is 10 plus 10 multiplied by cos 120. Cos phi kada. Cos phi ante cos 120, that is minus half. Andariki chudandi. So this whole expression simplifies to your tan alpha is equals to directly rastundi chuskondi. It is 5 root 3 kada. Numerator chuskondi okkasari. 2 cancel. 2 ones are 2, 2 5s are 10. Here is 10 minus 5. So ante 5. That means your tan alpha is equals to root 3. Ante your alpha is equals to tan alpha root 3 ante endira. Alpha is equals to 60 degrees. Ide kada. This is how you do the things. Try to understand. Okay, very good. Not 20. It should be 2 ones are 2, 2 5s are 10 kada 5. Kani it's minus 5. Minus 5. Minus 5. Enduko sir? Because minus half is there. Cos 120 value. Okay sir, children. Let us do one more question. Ante, choose kondira. Let me just conclude it. So if I have two SHM equations, choose kondi. Y1 is equals to 10 into sine of 4 into t. Ide kada? And if your second equation is of the form, Chapandi, what is the second equation? Your second equation is y2 is equals to 10 into sine of 4t plus 120 degree. If these are the two equations, this question lo coincidentally your a net is coming as 10. Yes. So y net gurinchi cheppalante your y net comes out as 10 ante a net value we calculated it multiplied by sine of omega t. Omega t ni common teeskondi. Omega t ante 4t kada. I'm sorry. It should be sine of 4t plus cheppandi ra. What was the angle coming? The angle was coming as 60 degrees. Chuskondi. Plus 60. Ide me resultant ante first you calculated the amplitudes. Malli dan tarvata you calculated the angle and chuskondi. This angle that is coming, this angle will always it will be between the two phases. Two phases ante entira. Me first phase lo it is just 4t kada. 4t ante 4t plus 0 ra chuskondi. Extra angle is 0. Your angle here is 120 and this 60 is coming between them. Between ante not exactly in the middle ra. These are all the coincidences. Chuskondi. But if at all your angle is to be calculated, I don't know how to zoom out the board. Okay, let me try zooming it out. I don't know. It should not be some other problem. Okay. Done. I hope it's visible now. Visible kada? Should I little zoom it up? Let it be, chat. It's good. Sir, good, very good. Let us take one more question, all of you, okay? Till you get a perfection. Choose one. Your first equation is your y1 is equals to 10 sine of 2t and your y2 is equals to, I should not say 10, I should tell you about 6, okay? Do it. Okay, I think now it will be able for you to do. Hi guys. Everybody try to understand. Hmm? Okay, getting it, not getting it wrong. So here, use the hint, all of you, okay? Try to use the hint. Hint and enti, sir. Your cause is there. Even before this, okay? In the beginning, in the first place, what you will be observing is the equations. Equations ni observe cheskondi. Your first equation is sine kada 6 sine of 2t ra. This is your first equation. 6 sine 2t. What about your second equation, sir? Your second equation is 8 into cos of omega t. Ante my first equation lo sine term untundi, my second equation lo cos term is there. You cannot add them. Chuskondi. Hi. Simple rule, ra. Simple rule. If you want to add them, terms must be same. Terms same undali. Terms ante your sine, it should be sine only. Are you understanding? Yes. So your first term is sine. Kani your second term is cos. Hey, ఇది చాలా misplacement రా. మరి ఏం చేయాలి? Convert. We know conversion కదా. I have given you the hint also. So you can tell, hi, good afternoon. You can tell your cos in terms of sine ra. Cheppandi okkasari. So here మీ second equation లో y2 is equals to 8 into cos of 2t. Ante you convert this cos into sine. It becomes 8 into sine of 2t. Okka extra pi by 2 add cheskondi. Ade when you are converting cos into sine ra, you will have to add pi by 2 in the face. Ide kada? Yes. So that means your equation becomes this ra. Ide ippudu this has become my y2 and my y1 is remaining the same ra. Okasari cheppandi, or y1 is equals to 6 into sine of 2. Idigo. ఇప్పుడు it's a very piece of cake కదా, simple equation రా. I have the values of a1, I have a2, I have 5. Formulas గుర్తుండాలి మాత్రమే. That's the biggest condition రా. చెప్పండి, your A-net formula. What is your A-net formula, sir? Your A-net formula is root of a1 square plus a2 square plus 2a1 a2 into cos 5. With you. Substitutes. One little observation to make అందరికి. Your 5 value is what రా? Pi by 2. అంటే ఈ ఈక్వేషన్ లో మీరు cos 5 వాల్యూ చూసి ఇట్ బికమ్స్ 0. సో ఇఫ్ ఇట్ ఇస్ 0 అంటే ఈ ఈక్వేషన్ కోసమే మాత్రం చూసుకోండి రా, దిస్ బికమ్స్ 0. అంటే యువర్ A-net is simply equals to root of a1 square plus a2 square. ఇదే కదా a1 square. a1 వాల్యూ చెప్పండి రా, 6 square plus 8 square. నాకు తెలిసి ఇట్ ఈస్ ఈక్వల్స్ టు 10 కాబట్టి రాస్తున్నాను. మీకు కావాలంటే ఒకసారి చూసుకోండి. Okay, this is your net amplitude. Only what about your phase angle ra? Phase angle kavali kada? Yes. So phase angle cheppandi. Very good. Very good. Very good. So for the phase angle, you can simply say, sir, your resultant equation y net will be of this form. Form chuskondi ra. A net sin of omega t plus you will take some random angle alpha kada. It is not equals to 5 and it is also not equals to 0. ఇప్పుడు చెప్పిన, I have told you multiple times, alpha is between your first and second phase. Understanding? Yes. So here A-net value 10 వచ్చింది sir. Your sin is sin only, omega t అంటే 2t only plus alpha value చెప్పండి రా. What is the formula for alpha, sir? We don't have formula for alpha, కానీ we have for tan alpha. Tan alpha అంటే a2 into sin phi divided by a1 plus a2 into cos phi. ఇదే కదా? Yes. ఇప్పుడు వాల్యూ సబ్స్టిట్యూట్ చేసుకోండి ఒకసారి. a2 అంటే 8, sin 5 అంటే sin 90 కదా 1 డివైడెడ్ బై a1 వాల్యూ ఇస్ 6 ప్లస్ cos 5 అంటే cos 90. ఎనీహౌ గెటింగ్ 0. యువర్ cos 90 cos 5 అంటే cos 90 రా, బికమ్ 0 అంటే ఐఎమ్ నాట్ రైటింగ్ ఇట్, లేదా 6 plus 0 రాసుకోండి, నో ప్రాబ్లం. 8/6 అంటే 2 4s are 8, 2 3s are 6. చూసుకోండి. యువర్ tan in theta is equals to 4/3. Tan theta 4/3 అంటే what is the value of theta ra? I know it. Okay, I know it. 53 degrees. Okay, so your tan alpha is equals to 4/3. కానీ నాకు తెలిసి tan of 53 is 4/3. Okay, సో ఇక్కడ నుంచి డైరెక్ట్లీ రాసుకోండి, alpha is equals to 53 degrees. ఇదిగో, సో ఇదే మీ రిజల్టెంట్ ఈక్వేషన్. So at this stage, all of you, I'm expecting, ఇదే అంటే it's not a chapter, right? It is a prerequisite of a chapter, okay? గుర్తుపెట్టుకోండి, ఇది చాలా 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 important. Try to understand, all of you, okay? Right. If at all you have two equations of two waves, okay, అంటే two SHMs. In general terms, మామూలుగా two SHMs ఉంటే it must be, లేదా you must be able to find the resultant of them. ఎలా క్యాలిక్యులేట్ చేయాలి సార్? యాంప్లిట్యూడ్ కోసమే మా దగ్గర వేరే మెథడ్ ఉంటుంది, and your phase angle, for your phase angle also we do have one different methods. Okay, that means you will be using two different approaches రా. కావాలంటే మళ్ళీ ఒక క్వశ్చన్ తీసుకోండి. I am not satisfied yet because it's the heart of this chapter. If you are weak at this heart, you will be gone. చూసుకోండి. Your first question is y1 is equals to a1 sin of 2t plus pi/3 and your not a1, it should be different. Okay, y1 is equals to 10, not 10. All the times I'm giving you 10 only. y1 is equals to 4 sin of 2t plus pi/3 and your y2 is equals to, తీసుకోండి అందరికి, y2 is equals to 6 sin of 2t plus pi/2. Let us take pi/6 for better purpose. చెప్పండి. Not pi/6 రా. You might get confused. Okay, it should be only omega t format, not something like this. చూసుకోండి, చెప్పండి. Everybody do it, okay? It might sound boring, sir. Why are you taking these boring questions to us? Kani, boring kadura. This is the soul of your chapter. If this is not good, your interference will be gone. Understanding? చెప్పండి అందరికి. So your A1 is equals to 4, A2 is equals to 6, pi is equals to pi by 3. ఇదే కదా, డైరెక్ట్లీ రాసుకోండి values అదే. And then you can directly write the formulas for your amplitudes also. And at the same time, you can directly write the formulas for your phase angles. చూసుకోండి. So your A net is equals to root of A1 square plus A2 square plus 2A1 A2 into cos phi. ఇదే కదా? Yes, చెప్పండి students, all of you. And if you are substituting the value, your A1 square into 4 square, A2 square into 6 square, plus 2 into A1 is 4, A2 is 6, cos pi by 3 అంటే cos 60. Cos 60 value half. ఇదిగో 2 gone రా. 2 gone. ఇదే కదా? Yes. 4 square 16, 6 square 36, and this becomes 24. ఇదే కదా? 36 plus 24 అంటే 60. 60 plus 16 అంటే 76. సో మీ A net అంటే root 76 వచ్చిందిరా. చూసుకో. Is it divisible by any perfect square? Keep it as it is. Okay. It's divisible by 4 actually. Okay, it's divisible. And let it be. This is A net ki value ra. And what about your angle alpha? Alpha cheppandi okasari. Your tan alpha is equals to A2 into sin phi divided by A1 plus A2 into cos phi. Ide kada? Yes. That means it will simply be equals to A2 value 6, sin 60 is root 3 by 2 plus A1 value is 4 plus A2 మళ్ళీ ఒక్కసారి cos 60 is half. ఇదే కదా? అంటే 3 root 3 divided by 4 plus 6 half అంటే 3. So that comes out to be 3 root 3 divided by 7. అంటే మీ alpha value it is equals to tan inverse of 3 root 3 by 7. ఇదిగో. These are the values. Right, correct. 2 root 90. Leda, whatever it is. Okay? So when you are writing about your net SHM, Y net is equals to A net ante root 76 sin of omega t plus alpha. Alpha value ikkada nunchi raskondi. Alpha ante enti sir? It is simply equals to it's a number, okay? Tan inverse of 3 root 3 upon 7. It's a number ra. Idigo, this is your net equation andariki. Kani there are some twists. Twists ante enti ra? Good, very good. The biggest twist is ఈ అన్నిటి equations లో, in all these equations, ఈ మొత్తం equations లో you only had a time term. అదే కదా? చూసుకోండి. Sin లో what you have రా? Time అంటే omega t. ఇదిగో. This is the only problem కదా? కానీ in your actual waves లో you don't have only time term రా. చూసుకోండి. Tell me the difference between these two equations. Okay, y1 is equals to a1 into sin of omega t and your y2 is equals to a1 leda your y1 leda, let us compare here your y1 is equals to a1 into sin of omega t plus kx. What is the difference, sir? What is the difference, sir? Cheppandi okasari. This is the place where most of the students don't understand the differences. Cheppandi, what is the difference between these two equations? If you know waves, very good, you will easily understand. If you don't know waves, just tell me what is visible ra. Difference cheppandi ade. ఈ రెండు ఈక్వేషన్స్ మధ్యలో what is the difference? What is the difference? అదే I only want the difference. Sir, మీ ఫస్ట్ ఈక్వేషన్ లో you don't have any x term, ఇదే కదా? Here x term is missing రా. కానీ మీ సెకండ్ ఈక్వేషన్ లో the same x term is there, ఇదే కదా? Yes. In your second equation that x term is already there, అంటే you do have x term. అంటే ఏంటిరా? That means you try to understand, okay? I'm now telling you the difference between these two equations. అంటే this is the equation for a particle, for a single particle. చూసుకోండి, this is the equation, చూసుకోండి, ఇదే అంటే this is the equation for a single oscillating particle. అదే కదా? కాబట్టి ఓన్లీ టైమ్ ఇస్ దేర్ రా. అంటే at what time, it is at what distance. అదే కానీ ఎక్కడ వచ్చేసి యూ కెన్ సింప్లీ సే ఇట్ ఈస్ ద ఈక్వేషన్. అందరికి చూడండి, దిస్ ఈస్ ద ఈక్వేషన్ ఫార్ what is the equation for? This is the equation for set of particles. అంటే which set of particles which are at a distance d. ఇదిగో, I'm sorry, x. అంటే you go from origin నుంచి x distance వెళ్ళండి. 1, 2, 3 meters ఏదైనా మీకు కావాలంటే తీసుకోండి. At 2 meters particle is fixed, ఇదే కదా? And that particle is oscillating. At 1 meter ఇది కూడా oscillating. 3 meters oscillating. There are multiple particles which are oscillating. So if you decide the value of x, you will get the particle. ఇప్పుడు ఈ పార్టికల్ కి మోషన్ చూసుకోండి టైం కి రెస్పెక్ట్ లో. అండర్స్టాండింగ్? సో నౌ యు ఆర్ అనలైజింగ్ దట్ ఈక్వేషన్ ఆఫ్ పార్టికల్ విత్ రెస్పెక్ట్ టు టైం. మళ్ళీ ఒక్కసారి డోంట్ టేక్ టూ మచ్ స్ట్రెస్ రా. ఓకే, టూ మచ్ స్ట్రెస్. ప్రాసెస్ ఇస్ వెరీ సింపుల్ చూసుకోండి. ఇప్పుడు ఐఎమ్ జస్ట్ టెల్లింగ్ యూ ద స్టెప్స్ వాట్ టు డూ రా. ఓకే, ఇప్పటిదాకా వాట్ ఎవర్ ఈక్వేషన్స్ వీ హ్యావ్ డిస్కస్డ్ దే వేర్ ఆఫ్ దిస్ ఫార్మ్ సార్. y1 is equals to a1 into sin of omega t, ఇదే కదా? Till now this was the first equation. y2 is equals to a2 into sin of omega t plus phi. ఇదిగోరా, there is no x term over here and there is some phi term కదా? Yes, there is no x term and there is a phi term. Try to understand the speciality of each and every equation ra. కానీ ఇప్పుడు the equations that we are going to see, they will have the x term ra. అందరికి చూసుకోండి. You are understanding? Yes. y1 is equals to a1 into sin of omega t plus kx1. గుర్తుపెట్టుకోండి. You are understanding? Yes. So this is the first equation. What about the second equation? Same process. y2 is equals to a2 times of sin of omega t plus kx2. ఇదిగో, these are the two equations now. ఇప్పుడు ఏం చేయాలంటే you have to add this. So sir, will the addition be exactly similar to this? No. కానీ a big portion will be similar to one another. ఇప్పుడు ఏం చేయాలంటే first of all you talk about the amplitudes ra. Formula is same. Whatever formula we will be using over here remains the same ra. అందరికి exactly same, ditto, 100% same formula, no change at all. You are understanding? Yes. అంటే when you write the amplitudes, అందరికి చెప్పండి ఒక్కసారి, your a net is equals to root of a1 square understanding? Are you understanding? Yes. So this is your net amplitude. We don't have to write about the NEET equation ra andariki. When the x term has been introduced, we are only interested about the amplitude. We are not interested about the phase. Endukante we are only talking about your constructive లేదా destructive interference. ఇదే కదా. yes, జాగ్రత్తగా వినండి ఇప్పుడు. okay, it is very important topic. all of you try to understand. ఇప్పుడు the biggest question that I have is, what is the value of phi? Here it was very easy kada. It was simply omega t. It was omega t plus phi. Whatever extra term is there, you write it ra. Are you understanding? Let us think the same process with another method ra. చూసుకోండి అందరికి. సో ఇదే my first phase కదా. సో ఈ phase ని phi 1 రాస్తున్నారు. And to this phase I'm naming it as phi 2 ra. So can I simply say, sir, phi, formula lo, this phi is nothing but the extra difference. Ide kada, extra ante enti ra, difference between the two. Extra ante difference. Ide kada. If you have extra 3 rupees ante your and my difference is 3 rupees ra. Ikkada kuda write the formula ante enti, you can simply say phi is equals to difference ante phi 2 minus phi 1 kada. Okasari substitute cheskondi ra. Phi 2 ante enti sir, ee mottam value omega t plus phi minus phi 1 value ante enti ra. Phi 1 value is omega t. Idigo your omega t or minus omega t gets cancelled and you got the value of phi. Ante your phi is nothing but phi 2 minus phi 1 ekkada kuda raskondi. Ide this is your entire value phi 1 andariki, and this is your entire value phi 2. ఈ ఫార్ములాలో your phi should be equals to phi 2 minus phi 1. ఇదే కదా. సబ్స్టిట్యూట్ చేసుకోండి. phi 2 అంటే your omega t plus kx2 minus phi 1 అంటే omega t plus kx. ఇదే కదా. వెరీ గుడ్, వెరీ గుడ్. ఇప్పుడు వాట్ యుల్ డూ ఇస్, చూసుకోండి, దిస్ omega t, this minus omega t gone. ఇదే kx2, this minus sign, okay, minus kx1 అంటే your kx2 minus kx1. If you want, you can take k common ra. Common తీసి తర్వాత your k into x2 minus x1 is remaining. అంటే this will be the value of phi. Okay, this is the value of phi. అందరికి చూసుకోండి. You want, you can write it. Try to understand. జాగ్రత్తగా అందరికి వినండి. ఓకే, who is calling me that all the times? Yes, so your phi అంటే k into x2 minus x1. ఇప్పుడు చూడండి, ఇప్పుడు try to understand. Okay, try to understand. So from this equation your a net should be equals to root of a1 square plus a2 square plus 2a1 a2 into cos phi. ఇప్పుడు what is the value of phi ra? Your phi is nothing but k into x2 minus x1. ఇదిగో, this is the values. Now try to understand everybody. These are the two equations kada. Yes, now I'm talking about these equations in detail ra. Okay, ఈ equations గురించి మాట్లాడుతున్నా, చూసుకోండి అందరికి. So when you are given with these two equations, till this point everything is clear kada. Yes, this equation is clear, no problem. ఇప్పుడు we will see what is this k ra. Step by step, we are going step by step, don't worry. చూసుకోండి. So first let me talk about this equation. చూసుకోండి, equation అంటే your y is equals to a into sine of omega t plus k into x. చూసుకోండి, the solid point number 1, this equation అంటే it is the equation of a moving లేదా the traveling wave. చూసుకోండి, అంటే if your string is like this ra, this is the equation of a wave that is going something like this. Try to understand. Point number 1 to be noted. Okay, traveling wave ante enti ra? If this is your string, okay, if this is your string, your traveling wave looks something like this. Idigo, this is the equation. Point number 1. Sir, is it only on the string? No. Chuskondi, we have different types of waves. Point number 1. Hey, it is the equation of a wave. It could be your sound wave. Yes, possible. It could be your sound wave. లేదా it could be your string wave that you generate on the string, లేదా it could be your water ripples. ఇదే కదా water ripples రా, when you throw the stone in the water some ripples are formed. ఇదే కదా, yes. లేదా it could be your light wave. చూసుకోండి, all these forms లేదా all of these waves have the same equation, same ditto, same to same equation. Your light wave ante your electric wave and your magnetic wave. EM waves chapter completed ra. Light wave ante your electric and your magnetic waves. And each chapter kosame this is the only topic we will be concerned about. We don't deal about all these things, right? Yeah, we don't want to talk about sounds, we don't want to talk about strings and also what. My only focus is about the light wave. Point number 1, చూసుకోండి. Point number 1, this equation is of a moving. అదే కదా. So ఒకటే ఈక్వేషన్ ఉంటే we have talked about the equation. కానీ if you have two different equations, చూసుకోండి రా, అంటే you have two different waves. ఇదే కదా, yes. Two different equations అంటే you have two different waves. Point number 1 గుర్తుపెట్టుకోండి. నెక్స్ట్ పాయింట్ రా, నెక్స్ట్ పాయింట్ చూసుకోండి. ఈ ఫార్ములాలో మీ దగ్గర రెండు వేరియబుల్స్ ఉన్నాయి. ద ఫస్ట్ వేరియబుల్ ఇస్ ఒమేగా. ఫార్ములాస్ మాత్రమే గుర్తుపెట్టుకోండి. ఇఫ్ యు ఆర్ నాట్ అండర్స్టాండింగ్ టూ డీటెయిల్డ్, ఓన్లీ రిమెంబర్ ద ఫార్ములాస్. ఇదే కదా, యువర్ ఒమేగా ఇస్ నథింగ్ బట్ 2π ఇంటూ ఎఫ్. వాట్ ఈస్ దిస్ ఎఫ్ సార్? ఎఫ్ అంటే ఫ్రీక్వెన్సీ. ఇదిగో ఫ్రీక్వెన్సీ అంటే ఏంటిరా? ఫ్రీక్వెన్సీ అంటే you have to create a wave, అంటే you have to shake your hands కదా. yes, up and down, up and down, up and down. అంటే ఒక్క సెకండ్ లో how many times you are oscillating it. so 1 2 3 అంటే my frequency becomes 3. 1 2 3 4 5 in 1 second, 1 second, 1 second, your frequency becomes 5. ఇదే కదా, yes. so omega is directly dependent on your frequency. so what is the relationship అంటే ఇదే. this is the relationship between your omega and frequency. what about this case sir? మీ k వాల్యూ అంటే ఇట్ ఈస్ 2π/λ. ఇది చాలా 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 ఇంపార్టెంట్, అందరికి జాగ్రత్తగా చూసుకోండి. లాంబ్డా అంటే ఏంటిరా? లాంబ్డా ఇస్ ద వేవ్ లెంత్ ఆఫ్ ద వేవ్. చూసుకోండి, లాంబ్డా అంటే ఇట్ ఈస్ ద వేవ్ లెంత్ ఆఫ్ ద వేవ్. అర్థమైంది కదా? ఇప్పుడు జాగ్రత్తగా చూసుకోండి. వేవ్ లెంత్ అంటే దిస్ డిస్టెన్స్ రా. ద వేవ్ స్టార్టెడ్ ఫ్రమ్ హియర్ up down and then it came down and then came to the same position. చూసుకోండి, one complete cycle తర్వాత whatever the distance is there, this distance is known as your wavelength అంటే lambda. చూసుకోండి, you are understanding? yes. ఇప్పుడు let us talk about something, this ratio రా. tell me omega upon k value. omega అంటే ఏంటి రా? omega అంటే 2πf కదా. yes, your omega is 2πf divided by k value చెప్పండి రా ఒక్కసారి. your k value is 2π/λ. substitute sir. 2π/λ. 2π gone అంటే your omega by k is equals to f divided by 1/λ. ఇదే కదా. yes, reverse it అంటే f into lambda. hey, f into lambda, speed of the wave అంటే it is equals to speed of the wave. just remember the results అందరికి. you are understanding? good. now let us take some more questions on this topic also ra. తీసుకోండి, this is your first question. find the frequency. okay, find the frequency and wavelength. okay, find the frequency and wavelength of the given wave. చూసుకోండి, I'm writing 2-3 equations రా. 2-3 equations రాస్తున్నాను. చూసుకోండి, the first equation is y is equals to 10 sine of 6t plus 4x. okay, next your y is equals to 10 sine of 4x plus 2t. Next, your y is equals to 2 sine of t by 2 minus x by 4. Calculate. What do you want, sir? You want the frequency and you also want the wavelengths. Yes. అంటే నాకు ఫ్రీక్వెన్సీ కావాలి, లాంబ్డా కావాలి. మళ్ళీ ఒకసారి ఐఎమ్ గివింగ్ యూ ద హింట్. చూసుకోండి రా, యువర్ ఒమేగా ఈజ్ ఈక్వల్స్ టు 2πf అండ్ యువర్ k ఈజ్ ఈక్వల్స్ టు 2π అపాన్ లాంబ్డా. ఇప్పుడు వాట్ ఈస్ దిస్ ఒమేగా ఇన్ k, సార్? చూసుకోండి రా, మీ ఒరిజినల్ ఈక్వేషన్స్ లో వాట్ వాజ్ ఒమేగా రా? ఒమేగా తర్వాత ఇమీడియట్లీ t హ్యాస్ కమ్. అంటే యువర్ ఒమేగా ఇస్ ద కోఎఫిషియంట్ ఆఫ్ t and your x your k is the coefficient of x. ఇదిగో ఒమేగా అంటే ఏంటిరా? ఒమేగా is your coefficient of t. Your k is the coefficient of తీసుకో. రైట్, చెప్పండి. రైట్, కరెక్ట్ చూద్దాం. సో మీ ఫస్ట్ కేసులో ఐఎమ్ వైపింగ్ ఇట్ అవుట్, ఓకే? లేదా వేర్ షుడ్ ఐ రైట్? లెట్ us మేక్ వన్ మోర్ స్లైడ్. 10 sin 60 plus 4x కదా. మీ ఫస్ట్ క్వశ్చన్లో y is equals to 10 sin of 60 plus 4x. ఎక్కడ నుంచి you must be able to write the direct values of omega and k రా. ఓకే, you must be able to write the direct value. omega అంటే coefficient of t అంటే 6 రా. ఇదిగో ఇది omega. and what about k, sir? k is the coefficient of x అంటే k value is 4. ఇదే కదా. ఇప్పుడు వాల్యూ చెప్పండి రా. omega is 2πf, that is equals to 6. k is 2π by lambda, that is equals to 4. So from here f is equals to 6 upon 2π, and from here your lambda is equals to 2π by 4. Simplify చేసుకోండి. Your frequency comes out as 3 upon pi and your wavelength comes out as pi upon 2. ఇదిగో, this is your first question అంటే first solution. Okay, right, perfect. Next, equation number 2 ra. 10 sin 4x plus 2t kida? Yes. So equation number 2 ante y is equals to 10 sin 4x plus 2t. Idigo. Directly your k value is 4. Why sir? Because coefficient of x. Coefficient of x kida? Yes. Your k value is 4. Chuskondi. What about your omega value ra? Your omega value is 2. Idigo. Finished. Finished. Ante your 2 pi by lambda is equals to 4 and your 2 pi f is equals to 2. Understanding? So from here you can simply say sir, lambda is 2 pi by 4 and your frequency is 2 upon 2 pi. 2 gone, 2 ones are 2, 2 2s are 4 until lambda is equals to pi by 2 and your frequency is 1 upon pi. Am I doing some mistake? Next question cheppandi ra okasari. Your next question is 2t sine of t by 2 minus x by 4 kada? Yes. So your equation number 3 is y equals to 2t sine of 2 sine of t by 2 minus x by 4 kada? Yes. Equation is 2 sine of t by 2 minus x by 4. What are the coefficients? ఇప్పుడు నాకు coefficients కావాలి కదా? Only the coefficients రా జాగ్రత్తగా చూసుకోండి. Your coefficients will be something like this. So this is my equation. Let's find. So visible ఇది. మొదటిగా you convert it రా. It is equals to 2 sine of. Can I say it is half into t అందరికి? t by 2 అంటే half into t కదా? Yes. Minus 1 by 4 into x. Finished. Your omega value is simply equals to 1 by 2 and your k value is equals to minus 1 by 4. Not minus 1 by 4. You only take plus ra, okay? Mods. Only 1 by 4. This is your values. Minus sign and it is traveling in the left or right side, something like that. Okay? I'm not going deep depth into it. If your kx term is negative, one it is going in positive x-axis. If both are different, if both have same sign, it is going negative or something like that. Leave it. You just tried omega value is 2 pi f. 2 pi f is equals to half and your 2 pi upon lambda is equals to 1 upon 4. So you can simply say lambda is equals to 8 pi e and from here you can simply say your frequency is 1 upon 4 pi. Correct. Very good. Very good. Very good. And last and fourth question kada. These two are important ra. A little important questions. Jagrataga vinandi. So your equation number 4 is what is it ra? T plus x by 2 kada? Yes, pi into t plus x by 2. Ante your y is equals to sine of pi into t plus x by 2. You understand andariki? Your amplitude does not contribute in finding your omega frequency leda your wavelength. Understanding? Amplitude is different and frequency wavelength they are different. Understand? Ippudu try to understand. It is nothing but your sine of multiply pi t plus directly rastunnam chuskondi pi by 2 into x. Idigo finished. Omega value is pi, coefficient of t and your k value is nothing but pi by 2. So you can simply say sir omega is nothing but 2 pi f is equals to pi and 2 pi by lambda is equals to pi by 2. Pi gone. Your f is equals to half. Ante in 1 second you are just making the half rotation. Ante your wave is traveling very slow. Something like this. You are able to understand? And wavelength you can do cross multiplication. Lambda is equals to 4 meters. Whatever the units are. Okay. So these are the questions. And in your last question, cheppandi 2 pi into 2t minus 4x kada? Yes. 2 pi into y is equals to 6 sine 2 pi into 2t minus 4x. Only okasari multiply. No problem at all. 6 into sine of 4 pi t minus 2 into 4 kada? Yes. 8 pi x. Your omega value is 4 pi and what about your k value sir? K value is nothing but 8 pi. జాగ్రత్తగా వినండి. అదే కదా, your omega is nothing but 2 pi f అంటే 4 pi, pi gone, 2 ones are 2, your frequency comes out to be 2. What about your wavelength రా? K అంటే 2 pi upon lambda is equals to 8 pi కదా, pi gone, 4, so from here your lambda comes out as 1 upon 4. Correct? It's correct. Okay, right. What we see in let me just quickly go through the overview. Andariki. So if you have two different waves, Andariki, if you have two different waves, A1 sine of omega t plus kx1, omega t plus kx1, and in the second equation, your second equation is omega t plus kx2. ఇప్పుడు when we are talking about the resultant amplitudes రా చూసుకోండి, resultant amplitudes గురించి మాట్లాడాలంటే you can simply say a net is equals to a1 square అంటే first amplitude square, a2 square అంటే second amplitude square plus 2a1 a2 into cos phi. ఇప్పుడు I have told you the value of phi. What is phi రా? Phi అంటే phase difference. Phase difference చూసుకోండి, ఈ phi అంటే phase difference రా. Here also the extra term అంటే phase difference కదా. Yes, here phi అంటే phase difference. Difference అంటే ఏంటిరా? You subtract this from this. అంటే phi2 minus phi1, k, all these things, okay? K into x2 minus x1 కదా. What is the value of k రా? K is 2 pi by lambda. 2 pi by lambda. Yes. అంటే 2 pi upon lambda into x2 minus x1. ఇదిగో, this is the value of phi. All of you try to understand. Understanding? Your phi is nothing but 2 pi by lambda into x2 minus x1. x2 అంటే ఏంటిరా? x2 is the position of the second particle. చూసుకో. If this is your string, ఈ string లో ఇదే, this is your x2, this is your x1. Subtraction కావాలంటే only this length I want కదా, delta x. You try to understand, okay? x2 minus x1 అంటే delta x. లేదా you can simply say, sir, your phi is nothing but 2 pi by lambda into delta x. ఇదిగో చూసుకోండి. Now I am telling you some terminologies అందరికి. First terminology అంటే phi. We call this phi as phase difference, okay? Phase difference రా, జాగ్రత్తగా వినండి. And this delta x లేదా x2 minus x1, we call it as your path difference. All of you, are you understanding? One is your phase difference and one is your path difference. Try to understand, everybody, okay? Right, correct. So let us go quickly and let us try to take the interference ra. First of all, all of you, your y1 equals to a1 sine of omega t plus kx1, and your y2 is a2 sine of omega t plus kx2. ఇదే కదా? Try to understand. Okay. Correct. Now, when you talk about later, when you are adding ra, when we actually what happens is, when you have two waves, you have a SHM under two SHMs. If you add the two SHMs, you get a new SHM. In new SHM lo separate amplitude undali and separate phase undali. ఇదే కదా. కానీ ఈ కేసులో we are not interested about the phase. అంటే నాకు only I want the value of the net amplitude. Net amplitude కోసం ఫార్ములా ఏంటిరా చెప్పండి ఒకసారి. You can simply say, sir, net amplitude A net is equals to, we have seen it multiple times, root of A1 square. It might be a little boring. Why are you repeating the formula, sir? Because I want all of you to remember, memorize, గుర్తుపెట్టుకోండి, by heart this formulas. At least 2 questions, okay? At least 2 questions from your chapter. A1 square plus A2 square plus 2A1 A2 into cos phi ra. ఇదిగో, understanding? A1 square అంటే ఏంటి సార్? I don't have any problem. కానీ the problem is only with the phi. Cos phi అంటే ఏంటి సార్? Phase difference. Have you noticed one thing ra? చూసుకోండి. I have taken the value of omega as same. Omega same అంటే 2 pi f is same. 2 pi f same అంటే frequency same. That means this entire result is only valid when the frequency of the waves is same, okay? When the frequency of the wave is same, frequency same కావాలిరా, అదే కాబట్టి then and only then you can tell it. Okay. From here you can simply say, sir, your phi is nothing but phase difference. Ide kada ee equation lo unte phi ra. This phi is nothing but phase difference. Kani we will write this phi. It is difference kada. So difference ante phi is equals to phi 2 minus phi 1. Ide kada. Can we modify this phi ra? Can we modify? Phi does not look good. Let us say it is delta phi ra. Oh, nice. Ante ee formula no, instead of phi we will be writing something as cos delta phi. Idi. Try to understand. You understand? Your delta phi is nothing but kx2 minus kx1 ante k into x2 minus x1. Ide kada k value entira 2 pi upon lambda. x2 minus x1 ante delta x. Idigo. So this is your delta phi value andariki. Are you able to understand? Your delta phi ante phase difference and your delta x ante path difference ra. Jagrataga vinandi. Now. My entire focus is on the formula. Gurtupeట్టుకోండి అందరికి. Hey, formula lo what you are seeing ra a square plus b square plus 2ab cos theta. Is it something familiar ra? Is it familiar? Is it familiar? Yes, it is. It is. చూసుకోండి. If I want the maximum value అంటే నాకు maximum value of this an కావాలంటే you have to assume some things రా. చూసుకోండి ఇప్పుడు సెపరేట్ గా ఫార్ములా గురించి మాట్లాడుతాం. Your a net is equals to root of a1 square plus a2 square plus 2a1 a2 into cos phi. ఇదే కదా? Yes. So if you want the maximum value of this expression రా, ఈ expression లో your cos phi should become 1. ఎందుకు sir? Because your a net is directly proportional to cos phi. చూసుకోండి. If your cos phi is more, your expression is more and your a net is more. If you don't understand in that way also, చూసుకోండి. This entire expression రా, చూసుకో. Your root of a1 square plus a2 square plus 2a1 a2 into cos phi. It lies between the two values. The two values are this ra. The first value root of a1 square plus a2 square plus 2a1 a2 and your second value is root of a1 square plus a2 square minus 2a1 a2. So this formula is less than this and more than this. Ante ఈ ఫార్ములాకి maximum value అంటే ఇదే and your minimum value అంటే ఇదే. ఇది కూడా. Are you able to understand? So if you are talking about the maximum value, where is cos phi? It became equal to 1. Understanding? Cos phi equals to 1 ra. కాబట్టి this formula వచ్చింది. Understanding? What about the minimum value ra? Your cos phi should become minus 1. చూసుకోండి. Your cos phi should become minus 1 కదా? Yes, minus 1 రా, minus 1. అంటే you have two more conditions now. అందరికి it is slowly unfolding, okay, unwinding the loops. జాగ్రత్తగా వినండి. అంటే ఈ ఈక్వేషన్ లో you have two cases. First case is for your maximum value రా and the second case is for your minimum. Minimum of what రా? A net కి maximum value కోసం మీ cos phi 1 ఉండాలి. And a net ki minimum value kosam your cos phi minus 1 undali. Ide kada? Yes. So you can simply say, sir, maximum value kosam your cos phi should be equals to 1 and here your cos phi should be equals to minus 1. Idigo. Are you understanding? Now when your cos phi is 1 ra, 0, 2 pi, 4 pi, 6 pi, 8 pi, all these things. Ade kada? Yes, ante your phi value should either be 0 లేదా 2 pi లేదా 4 pi, I'm sorry, లేదా 6 pi. Understanding? Ante when you substitute 0 as your phi, it will give you 1. When you substitute 2 pi instead of phi, it gives you 1. Are you understanding? That simply means ra, ఇక్కడ నుంచి you can simply say this equation is satisfied by some values of phi. So values ఏంటంటే 0, 2 pi, 4 pi, 6 pi. చూసుకోండి. అంటే you can simply say your phi అంటే this phi cos phi లో phi it must be equals to 0 లేదా your phi must be equals to 2 pi లేదా it must be equals to 4 pi, లేదా it must be equals to 6 pi and so on so forth. You can guess it కదా. ఒక జనరల్గా లేదా మామూలుగా ఫార్ములా రావాలంటే if you want the normal or లేదా the general formula, what you will say ra, you can simply say your phi is equals to 2n pi. ఎప్పుడు ఈ n కి వాల్యూ మార్చేసుకోండి, ఆటోమేటికలీ యూ విల్ బి గెటింగ్ డిఫరెంట్ వాల్యూస్. n వాల్యూ 0 పెట్టండి రా 0, n వాల్యూ 1 2 పై, n వాల్యూ 2 4 పై, n వాల్యూ 3 6 పై. అంటే I got the pattern. Yes, we got the pattern. That means you can simply say, sir, your phi should be equals to 2n pi ra. కానీ we've seen about the value of phi. What is the value of phi ra? ఇదే same phi కదా, same phi ra, 2 pi by lambda into delta x. చూసుకో. That's why I've told you to find the values of wavelengths of the wave and frequencies of the wave. Why? Because if you are good with those things, you will be good with here also. Phi ante 2 pi by lambda multiplied by delta x should be equals to 2n pi. చూసుకోండి రా, ఈ ఈక్వేషన్ నుంచి 2 gone, pi కూడా gone. అంటే your delta x divided by lambda should be equals to n, and that means your delta x should be equals to n lambda. Delta x అంటే ఏంటిరా? పాత్ డిఫరెన్స్. అంతే కదా, పాత్ డిఫరెన్స్. చూడండి, your delta x is nothing but x2 minus x1. అందరికి I'll tell you, don't worry. అంటే that must be equals to n అంటే ఇంటీజర్ రా, ఇంటీజర్. ఇదిగో ఇది చాలా ఇంపార్టెంట్. ఓకే, n must be an integer. It's not any number, right? It's an integer. n lambda అంటే your path difference delta x should be equals to 1 lambda లేదా 2 lambda లేదా 3 lambda and so on so forth. It could be 0 lambda also. Ante 0, it could be minus lambda, minus 2 lambda and so on so forth. Are you understanding? These values are possible. Ante meeku maximum value of amplitude kavalante, your path difference of the waves should be an integral multiple of wavelength of the wave. Point number 1 to be noted. Dan tarvata, when we are talking about the minimum value గురించి చెప్పండి. What you can say is, for your minimum value, your A net is equals to root of A1 square plus A2 square. It should not be plus, it should be minus 2A1 A2 into cos phi. ఇదే కదా, this is the minimum value. But what was the general result? General result, bro, your A net was coming as root of A1 square plus A2 square plus 2A1 A2 cos phi. Compare చేసుకోండి ఒకసారి. Your cos phi has been replaced by -1. You see it, right? It is -1 కదా, same. అంటే your cos phi should be equals to -1. Do you understanding? Now the biggest question is, what is the value of phi? Cos pi 180, cos 180 degree ante cos pi is -1, cos 3 pi is -1, cos 5 pi is -1, cos 7 pi is -1. Very good. Ante your value of phi should be equals to pi లేదా 3 pi లేదా 5 pi లేదా 7 pi and so on. Can I make it a formula? Yes, you can. You can simply say it should be 2n plus 1 into pi ra. ఇదిగో n value 0 పెట్టండి. n value 0 అంటే pi, n value 1 అంటే 3 pi, n value 2 అంటే 5 pi and so on so forth. అదే కదా. So your phi, what is the value of phi? Sir, 2 pi by lambda into delta x. ఇదిగో రా, I've told you multiple times. It should not be a factor of doubt at all. If at all in chapter you are getting confused, sir, why am I writing this? Until you have not learned anything in your previous chapters. Okay, correct. So you can simply say 2 into n plus 1 multiplied by pi. Chudandi, pi gone kada. You send that to this side. Ekkad nunchi you can simply say, sir, we are left with 2 upon lambda is equals to 2n plus 1. Ide kada? 2 upon lambda is 2n plus 1. 2 pi by lambda into delta x into delta x into delta x should be equals to 2n plus 1. Ide kada? Yes. So you send this entire value that side. Ante 2 upon lambda, you send it. It gets upside down kada? Yes. So your delta x remains 2n plus 1 multiplied by upside down 2 by lambda becomes lambda by 2. Idigo. This is the value. If you want, you can send that to inside ante you can simply say your delta x should be equals to directly rastunnam chuskondi andariki n plus half into lambda. Idigo. This is for your minimum value. Try to understand andariki, okay? Minimum value kosame ante this is the formula. Ippudu we have also not seen one more aspect One more aspect ante enti sir? Is this formula? Hey, are you able to understand something from this formula, sir? Root of a1 squared plus a2 squared minus 2a1 a2. Hey, you are able to click something a1 square plus a2 square minus 2a1 a2. A square plus b square minus 2ab a square plus b square minus 2ab. A minus b whole square. Ante your a net is equals to root of a1 minus a2 whole square. Root square gone okay? And you can simply say a net is equals to a1 minus a2. It's a very special case where you have the minimum value of amplitude. Idigo. And when is it happening? It is only happening when your wavelength, your path difference is this times your wavelength. Okay? What about the maxima? Maxima gurinchi cheppandi okasari. The same process. It is 2a1 a2 kada. This is for the maximum value andariki. So it's a maximum value ante we should have write your a net should be equals to root of a1 square plus a2 square plus 2a1 a2. Idigo. Your understanding ante root of a1 plus a2 ki whole square, root square gone, your a net comes out to be simply a1 plus a2. Understanding ante, let us quickly summarize everything okay? Everything so that it gets fitted in your mind చూసుకోండి. ఇప్పటిదాకా whatever we discussed ante it was a simple time based equation. కానీ when you talk about the position also, you have two different waves. చూసుకోండి. y1 is equals to a1 into sine of omega t plus kx1. y2 is equals to a2 into sine of omega t plus kx2. ఇదే కదా? These are the two equations. Two equations అంటే two different waves that are traveling. Try to understand. Two different waves that are traveling this ante my first wave, okay? For example, let us say this is, hey sir, how are you drawing, sir? Nothing has been mentioned. Don't worry. Everything will be assumed You understand, this is your first wave and this is your second wave idigo. They are meeting at a general point. Ide kada? Try to understand. Okay? Chala important. Now, let us say here is the source S1 of the wave and here is the source S2 of the wave. Idigo. So what we say is we simply talk about the distances. So ikkada nunchi ekkada varaku distance ante let us say this distance is x1 andariki. And from source 2 to the point of intersection, let us say distance is x2 Are you understanding? X1 ante distance of the source of the first wave from the point of intersection. x2 ante distance of the source of the second wave from the point of intersection. Ippudu when you talk about the amplitudes when you are adding them, we do have two aspects kada. Na daggara rendu aspects untundi. First aspect is your amplitude, second aspect is your phase angle. Kani I'm not concerned about the phase angle because it may increase, it may decrease Kani I need the extreme conditions. Extreme conditions ante enti Naku amplitude gurinchi maatladali. So a net is equals to root of a1 square plus a2 square plus 2a1 a2 into cos phi What is this phi, sir? Phi is the difference between the phase angles. Ante your phi value is nothing but phi 2 minus phi 1. Phi 2 ante enti, sir? This మొత్తం subtract చేసుకోండి you are directly left with kx2 minus kx1 ఎందుకంటే omega t cancel అవుతుంది. So k into in bracket x2 minus x1 k value is 2 pi by lambda into x2 minus x1. ఇదిగో x2 value అంటే this path difference source of second wave from distance of intersection x1 ante distance of source of first wave from point of intersection. Ardhamaindi? Yes. So now you can simply say, sir, this is the value of your phi. Idigo. Hey, ఇది చాలా important ra. Now there are two cases depending upon the value of phi kada. Yes. So if your phi value is equals to 2n pi. 2n pi ante maximum అంటే ఏంటి రా? You can simply say, sir, a net is equals to a1 plus a2 ra. Finished. What about the minimum value ra? Your phi value should be equals to 2n plus 1 into pi. ఇదే కదా? అంటే this is for the minimum. Try to understand everybody. Maximum kosame, we did entire calculation and we got the value of delta x should be equals to n into lambda ra. ఇదిగో. And for this condition, you need your delta x should be equals to n plus half into lambda. ఇదే కదా? Yes. So if it's a maximum, it's a minimum. Minimum question you can simply say, sir, a net is equals to a1 minus a2 ra. Now they have only given the names. Maximum ante they tell it ra. Scientists got mad. Okay? They say it to be a constructive interference. They just tell it. So ippadi nunchi gurtupetukondi, constructive interference ante it's a maximum condition of amplitudes. Okay? Constructive interference. And they call it as destructive interference. Something got crazy, okay? Gone mad, and they're telling all these things to us. Destructive interference. This is చాలా important. All of you try to understand. These are the types of interference ante meetings, combinations, superpositions. Okay, resultant. Okay. Sorry. So these are the two values, లేదా two different cases of interference of waves. Good petkondi. This is చాలా important. Okay, am I forgetting something? No, I'm not forgetting something. చూసుకోండి రా. Now అందరికి there is something known as intensity of the wave. Okay, intensity అంటే ఏంటిరా? Intensity ఇదిగో, I've told you in the waves itself. If you have seen my wave lecture, లేదంటే if you haven't seen it, I'm explaining it here also. Intensity ante strength ra. Ante if the light intensity more, you will see more brightness. You are understanding? Na దగ్గర రెండు torches ఉంటే one is dim, one is bright. Ante the intensity is more. Here intensity is less. Same thing. Your sound that is coming, loud sound, volume ante volume of the sound kada. Volume ante intensity. High intensity unte the volume is more. Low intensity unte volume is less. Ide kada? Yes. So your intensity, చూసుకోండి, your intensity, the actual formula is 2 pi square f square a square rho into v. ide. This is the intensity formula that I have discussed in waves. Kani, if you don't remember this formula, no problem. Just try to understand that your intensity is directly proportional to a square. Mari a ante enti sir? Amplitude. Understanding? Amplitude. Yes. Lunch break will be at 1:30 andariki. 1:30. Lunch break will be at 1:30. Okay, your intensity is directly proportional to amplitude square. F ante frequency, okay? ఈ ఫార్ములాలో intensity is 2 pi square f square a square root. V అంటే speed of wave. Okay. Rho అంటే density of material లేదా medium, whatever it is traveling through. Density of medium ra. A అంటే amplitude of wave. And F is your frequency of the wave. 2 pi, you know it. You want to remember, లేదంటే leave it. Okay, right. Let us see all of you. Your intensity is directly proportional to a square. ఇదే కదా? That means you can simply write the formula now. Sir, A net is a root of A1 square plus A2 square plus 2A1 A2 into cos phi. ఇదే కదా? We will see everything in terms of intensity now. So it comes out to be A1 squared అంటే I1 కదా? Yes. Plus A2 squared అంటే I2 కదా? Yes. Plus 2 into, ఇప్పుడు A1 కావాలి రా. What can I say? ఇప్పుడు root I is directly proportional to A. అంటే a1 కి ప్లేస్ లో I will write root of I1, a2 కి ప్లేస్ లో I will write root of I2 into cos phi. ఇదిగో this is the formula for your resultant intensity square root. Square root of resultant intensity. If you want, you can square it. Square చేసిన తర్వాత you are left with your net intensity is I1 plus I2 plus 2 into root of I1 I2 into cos phi. Again, same principle. If it's a maximum కోసం cos phi should be 1 and your delta x should be integral multiple of wavelength. Minimum ఉంటే cos phi should be -1, your delta phi లేదా delta x should be n minus half times your wavelength. Okay? For maximum hey చూసుకోండి, for your maxima condition same things. Here we will talk about your maxima, here we will talk about your minima. So మీ maxima కోసం చెప్పండి, your I net should be equals to I1 plus I2 plus 2 into root of I1 I2 cos phi kada, cos phi value must be 1 ante gone. So you can simply say, sir, this is nothing but root of I1 square plus root of I2 square plus 2 into root of I1 into root of I2. చూసుకోండి, a square plus b square plus 2ab kada, that means root of I1 plus root of I2 whole square. So this is your intensity net, ante your maximum intensity is equal to root of I1 plus root of I2 whole square. Alage the same process, instead of plus it is minus ante you can directly say your I minimum should be equals to root of I1 minus root of I2 whole square. చూసుకోండి, ఇది చాలా important formulas. Okay, these are the actual important formulas to understand. చూసుకోండి, these are your intensity conditions for maxima and minima. అర్థమైంది అందరికీ? Right. So with that all being said, let us jump into your wave optics. అంటే it has been completed. We have already discussed about your intensity, అంటే interference of waves we have already discussed. కానీ the same results are useful. Okay, the same results. If you want, let me just go and finish Young's double slit experiment కానీ ఆ కోసం we need some concepts అంటే your Huygens theory. Okay, చూసుకోండి, what is light? Optics అంటే ఏంటిరా? Try to understand. Okay, optics అంటే you have two types of optics: geometrical optics, ray optics, and the second optics is your wave optics. Optics అంటే ఏంటిరా? Optics, hey, did you hear the name before? Optics, optical instruments. Hey, optical center. Optics ante simply light. Understanding? Yes. Optics ante light. The biggest question is, how do you sense the light? చూసుకోండి, your eye has a retina. Okay, on that retina the light falls. Hey, try to understand. Okay, correct. చూసుకోండి, ఆప్టిక్స్ అంటే ఇట్ ఈస్ సింప్లీ యువర్ లైట్ ఈ లైట్ ని స్టడీ చేయడానికి వీ హ్యావ్ డివైడెడ్ ఇట్ టూ డిఫరెంట్ టైప్స్, అంటే యువర్ రే ఆప్టిక్స్ అండ్ లాస్ట్లీ యువర్ వేవ్ ఆప్టిక్స్. అంటే ఏంటిరా? ఇన్ యువర్ రే ఆప్టిక్స్ వీ విల్ బి స్టడీయింగ్ ద light assuming the particle nature అంటే reflection of light, refraction of light, energy, momentum, all these things. Okay, and when you talk about your wave optics, wave optics you can assume the light as a wave, and we study all the wave related patterns, equations, interference, all these things. Okay, all these things we'll be studying in your wave optics. చూసుకోండి, so light అంటే ఏంటి సార్? Light is a wave. Okay, light అంటే it is your EM wave ఈ చాప్టర్ కి డొమైన్ లో ఐఎమ్ టెలింగ్ యూ యువర్ లైట్ ఈస్ నథింగ్ బట్ ద EM wave. EM wave అంటే ఈ వేవ్ లో యూ హ్యావ్ టూ టైప్స్ ఆఫ్ వేవ్స్ ఫస్ట్ ఈజ్ యువర్ ఎలక్ట్రిక్ వేవ్ అండ్ నెక్స్ట్ ఈజ్ యువర్ మ్యాగ్నెటిక్ వేవ్. చూసుకోండి, ఇదే దిస్ ఈజ్ యువర్ మ్యాగ్నెటిక్ వేవ్. ట్రై టు అండర్స్టాండ్. ఓకే, your electric wave oscillates up and down, magnetic wave oscillates back and forth. అంటే perpendicular waves. They are both the perpendicular waves. Something like this. చూసుకోండి, ఇదే కదా? Yes. And your second wave looks something like this. Perpendicular. They are perpendicular. Try to understand. ఇప్పుడు you understand in EM waves also we studied this formula ra E naught is equals to B naught into C ఇదే కదా అంటే your electric field value is too large చాలా high చాలా your magnetic field is very low so when the light falls in your ears ra eyes light falls in your eyes okay yes so yes, electric wave and magnetic wave perpendicular to each other. Very good. So when the light is falling on your eye, ante ee light lo unte electric component, electric field, it is sending some signals. Electric field ante charges kada. Yes, it's like giving shock, little chinna shock. It is giving chinna shock to your retina. Ade there is some interaction between the electrons and the charges. Something on your retina is happening, and that interaction your brain perceives it as an image. But actually it is nothing but the interaction of your electric component of the wave. Electric component, it goes into your eyes and gives a shock to your retina. Understanding? Signals, electric signals. An interaction between the charged particles. That shock, లేదా that signal, you classify it into your vision. Vision ante pictures. Understanding? Yes, good. ఇప్పుడు there were theories about light. What is light ra? So మొదటిగా Newton said light is a particle. అంటే particle nature గురించి he has explained. Corpuscular theory of light. He also named the light particles to be corpuscles ra, okay? Corpuscles. దాని తర్వాత there came scientists like your De Broglie, okay? Like your Schrodinger. They proved that light is a wave. Malli there came Einstein that explained photoelectric effect and he told that light is a particle. So what is the widely accepted nature? Not accepted, right? Is the reality until light has both the natures. Until light behaves as particles also and waves also. And depending upon the situation, if you are looking at on a very small scale, light behaves as a wave. Understanding? If you are looking at a very large scale, until the light coming from this bulb, it is a particle for me. You have to understand. It's carrying some energies, the momentum and energies. So for me, when I am looking at it from a bigger perspective, I do say that it's a particle. Kani, when I am looking at it from a very small scale, until I'll just see the, we'll talk about it. Okay? Young's double slit experiment. Yes. For those experiment, light is a wave. Ante kada? Yes. So ee chapter kosam, we will assume light is a wave. Endukante ee chapter lo we are looking the light from a very small perspective. You are understanding? Right. Correct. So we will assume the light to be a wave. Okay? We will assume the light to be a wave. Who was the person, ra? Huygens was the person who said that light travels like a wave. Wave ante entira 1:13 kada. We'll take a break on 1:30 sharp 1:30. So till that I think I'll be completing your Huygens theory. Okay? So Huygens gave us a theory ra, చూసుకోండి. పేరు Huygens theory అంటారు. I don't want to go much details. Okay? Not useful for you. At least at this stage it will be waste of time. Remember only three things ra. Remember only three things about this theory. Point number one. Light travels along. No, light travels in a waveform. Yes. Next, he had said that there are some light sources. Ante enti? You try to understand. ఈ ఈక్వేషన్స్ లేదా ఈ చాప్టర్ కోసం వీల్ టేక్ కార్డ్బోర్డ్ అంటే తెలుసారా? యువర్ షీట్ ఆఫ్ పేపర్ షీట్ లేదా యువర్ పేజ్ పేపర్ పేజ్. యూ డూ వన్ థింగ్, యూ టేక్ యువర్ పేపర్ పేజ్, ఇదే మీ పేజ్ ఉంటే యూ టేక్ ద బ్లేడ్ అండ్ హిట్ అ స్మాల్ కట్ ఆన్ ఇట్. స్మాల్ కట్ అండర్స్టాండింగ్. అండ్ ఈ కట్ నుంచి పాస్ చేసుకోండి ద లైట్. You pass the light from this small cut. Are you understanding? The blade thickness is very small, and from that cut you are passing your light. Ante Are you understanding how small level we are observing? Very small, very small, very small level. So what will happen in there? This light, I should just take a cross section. Choose good. So when I see the cross section of the paper, I will see something like this. This is a small cut that we made. Small cut, chinna cut. Choose good. This is the small cut that you have made. I think now it's understood. Is it visible? Hey, choose kora. There is this small cut, okay? It is the small cut. Choose kora. So actually it's a very large when you zoom it up. But for our frames, we will simply say it's a small cut that you have hit. Yes. So very small cut. What you are doing now is you are actually throwing some light. Choose kora. You are actually throwing some light from the opposite side of this cut sheet. All this. These are the light. ఇప్పుడు ఏమైతుంది అంటే whatever the lights will come out, చూసుకోండి అందరికి, whatever the lights will come out, I'm taking the same color. Yes, so if this is a light source చూసుకోండి, the light source is here. Point number 1 of Huygens theory, what is it? Light travels in a wave. దాని తర్వాత the second thing చూసుకోండి, light travels in such a way that all the points on the given axis, not axis, I should not say axis, what should I say? How should I tell you? Okay, the second thing that he told was about wave fronts. చూసుకోండి wave fronts, wave fronts చూసుకోండి, wave fronts లేదా wavelets. Names might be confusing. Wave fronts లేదా wavelets అంటే తెలుసా? ఈ చాప్టర్ కోసం we are assuming light as a wave. Point number 1. Understand? Hey, all of you. This light behaves as a wave. Wave అంటే amplitude ఉండాలి, phase గుర్తుందా? phase లేదా phases ఉండాలి. So you need two conditions మొదటిగా you talk about your amplitude, ఇదే కదా, and you talk about the phase అందరికి చూసుకోండి, phase. So when you talk about phase, two waves, I have two waves, okay, they are oscillating something like this, and both waves are in the same phase. Are you understanding? Aligned motion kada, synchronized motion try to understand. Both waves, they are moving in the same phase. When sir? Because when you say that they are traveling in the same direction at all the times, you are understanding? And if this is my light source, all of you try to understand. Water ripples kada, water ripples, exactly the same thing you try to understand something like this. So drop some object into the water ఏమైతది అంటే there will be ripples forming, అదే కదా? Yes, so this is a stone that you have dropped, these are the ripples forming అందరికి చూసుకోండి, these are the ripples కదా? Yes, so if these are the ripples, I will simply say అందరికి చూసుకోండి, each and every point on this ripple ఈ మొత్తం points కోసం phase అంటే same, అంటే each and every point on this is oscillating in the same phase. You're understanding? Ante if one is at the top position, second is also at the top position. Try to understand. Same works for light also try to understand andariki. Ante if this is your light, it throws your ripples. Try to understand. So these are the ripples kada? Yes, so these are the ripples of a light. Here ripples ni we will call them as wave fronts లేదా wavelengths. Try to understand. Okay? Yes. So sir, this is your first wave front, second wave front, third wave front, fourth wave front, and so on. For a point source, ఒక point source కోసం మీ wave front have the shape of a sphere. Okay? For a point source of light, your wave fronts are having the shape of sphere. Okay? Sphere. Good. అంటే these are your wave fronts. చూసుకోండి, this is a source of light కదా, ఇదే మీ source of light. What source, sir? We name this source as primary source. అదే కదా? Yes. Point number 1, hey, Huygens theory గురించి points గుర్తుపెట్టుకోండి. First, light travels in a waveform. The points which oscillate in same phase, they are called as the wavefronts or the wavelets. Ide kada? Yes. And lastly, when you talk about the sources, this is your primary source. And last topic of this theory, చూసుకోండి. Each and every point on the wavefronts, okay? Each and every point on the wavefront. Each and every point on the wavefront. This. Last point చూసుకోండి అందరికి. దాని తర్వాత we'll take a break. Okay? Third topic is each point on the wavefront. Each point on the wavefront. Waveform acts as a secondary source. అంటే ఏంటిరా? Source అంటే తెలుసా? The light rays are emitted from the source. చూసుకోండి. Acts as a secondary source రా. ఇదిగో. So that means this point acts as a source itself రా. అంటే it will emit lights. This will also become as a source. This will also act as a source. This will also act as a source. ఇది కూడా as a source, as a source, as a source. You're understanding? Acting as a source అంటే creating its own ripples. Creating its own ripples రా. And last topic చూసుకోండి. The tangents joining the secondary sources is the next wavefront. అదే అంటే ఏంటిరా? Try to understand. I'll explain it here. Okay, it is my first slide. ఈ ఫస్ట్ స్లైడ్ లో ఐఎమ్ ప్లేసింగ్ అ లైట్ సోర్స్ అందరికి. దిస్ ఈజ్ మై లైట్ సోర్స్. ఓకే, సో లైట్ రేస్ ఆర్ గోయింగ్ ఆల్ ద వేస్. అంటే ఇక్కడ నుంచి యువర్ ఫస్ట్ రిపల్ ఇస్ లైక్ దిస్. రిపల్ ఇదే మీ ఫస్ట్ రిపల్. ఎవ్రీ పాయింట్ ఆన్ దిస్ రిపల్ ఇస్ యాక్టింగ్ యాజ్ ఇండిపెండెంట్ రిపల్. ఇదే కదా? ఎస్. సో దిస్ పాయింట్ యాక్టింగ్ యాజ్ ఇండిపెండెంట్ రిపల్స్. అంటే దే విల్ క్రియేట్ దేర్ ఓన్ రిపల్స్ రా. ఫస్ట్ వన్, సెకండ్ రిపల్, థర్డ్ రిపల్. Ripple versus ripple. Okay, fifth point. Idigo. Now when you draw the tangents andariki chuskondi, your tangents ante something like this. Say tangent. This becomes your second wavefront. Understand? Something like this. Idigo. This is your source of light. Ekkadi nunchi your ripple has been formed. ఈ రిపల్ లో ఉంటే ఈచ్ అండ్ ఎవ్రీ పాయింట్ ఇట్ ఈస్ యాక్టింగ్ యాజ్ ఇండిపెండెంట్ సోర్స్ ఆఫ్ లైట్ కదా. ఎస్. సో దీస్ ఆర్ ద ఇండిపెండెంట్ సోర్సెస్ ఆఫ్ లైట్స్ రా. ఎప్పుడు ఏమైతుంది అంటే దే విల్ క్రియేట్ దేర్ ఓన్ రిపల్స్ రా. అదే దిస్ ఈజ్ యువర్ ఫస్ట్ రిపల్, దిస్ రిపల్ డ్యూ టు దిస్ పాయింట్, దిస్ డ్యూ టు దిస్ డ్యూ టు దిస్. అండ్ ఈ మొత్తం రిపల్స్ తోనే యూ డ్రా టాంజెంట్ లైన్ రా. అంటే దిస్ ఈజ్ యువర్ సెకండ్ వేవ్ ఫ్రంట్. ఇదే కదా? This is your first wavefront, second wavefront. Malli the same process. These are the points on this wavefront. They will act as independent sources until it will create ripples, something like this. And you draw the tangent, you will get third wavefront, and so on and so forth. It will get continued. Okay, right. Let us take a break now. Okay, let us take a break. Now let's take a break. Everybody is insisting on breaks only, sir. So break this one. Very important, okay? Very important. Done. Hi. Surprise. Okay, so let us continue. Andariki. Yes, so we're talking about your interference, kada? Yes. Good afternoon, everybody. Good afternoon. Please check your question. I don't think that question is yes, done. I don't think the question is right. Okay, please check the question. Two light waves are represented by y1 is equals to a sine omega t and y2 is equals to a sine omega plus t. I don't think the question is correct. Anyways, let us stop. So, we're talking about YDSE kada, Young's double slit experiment cases. Then we'll talk about diffraction of light and then we will be talking about polarization and then the chapter is completed. Okay, choose one. And then once again, let me quickly revise to you. All of you try to understand. Delta x. Okay. I will ask you a question, Ra. Okay. Choose them. How many of you can answer that question correctly? Chinna conceptual question, right? Okay. Let us see. Before that, let me just quickly go through the resultant of the waves. Y1 is equals to A1. Y1 is equals to A1 sine of omega t. Yes, omega t plus kx1. And similarly, Y2 is equals to A2 times of sine of omega t plus kx2. Yes. Condition. Cheppandira, A net formula. Modatiga, first of all, you tell me this A net formula, sir. A net is equals to root of A1 square plus A2 square plus 2A1 A2 into cos phi. Very good, sir. What about phi, sir? Phi is nothing but k into in bracket x2 minus x1. And your phase difference is nothing but 2 pi by lambda into in bracket x2 minus x1. Understanding? Right. Correct. Now, let us take two sources. Okay, we have seen about formulas a lot. Let us take a question. Okay? The question, let us try to understand. All of you, try to understand. This is the source S1 of light. Okay? S1. S1 nunchi, let us say the distance over here is somewhere around 8 meters. Okay? 8 meters of distance is there. This source is S2. S2. Right. and exactly from the middle, this distance over here is 3 meters of distance. And this 8 meter is classified into 4 meters and 4 meters. There you go. So here, you imagine, this na first wave that is colliding over here, this na second wave that is going and that is interfacing here. The question is, what is the value of delta x? Hi. Delta x ki values cheppandi andariki. What is the value of delta x? So the question is the path difference for the following situation. The path difference, okay? The path difference for the following condition is dash. Option A. 4 and 4 అంటే 8 meters. Okay, లేదా option B, it is 3 అంటే 3 meters. Option C రా, path difference is root of 3 square plus 4 square అంటే 5 కదా, yes 5 meters. లేదా option D is 0 meters. చెప్పండి, what is the answer రా? The option. Hi. Hello everybody. Hello. Path difference చెప్పండి రా. Yes, correct. 0. ఎందుకంటే you take the value of x1 and x2. Take the value of x1 and x2. Okay, x1 and x2. Correct. x1 is 5 and x2 కూడా 5 కదా. Yes. So if both are same, x1 minus x2 is 0. Next question, చూడండి అందరికి. This is my source S1, okay? This is my source S2 రా అందరికి. Let us say the distance between the two sources is 10 meters. In the 10 meters. It's a very complicated question. Complicated అంటే conceptual question, okay? Yes. Right. Let us say, లేదా I should not give you 10 lambda. Let us say the distance is 10 lambda. Lambda into the wavelength of the light. You understand me? Yes. The wavelength of the light ra. The question is exactly in the center. Center ante telusa. Will it be minima or maxima? Will it be minima or maxima? చెప్పండి. Exactly at the center ra. Okay. Hi. Maxima. Correct. Why maxima? ఎందుకంటే the distances చూసుకోండిరా. 10 lambda ఉంటే this is 5 lambda. This is 5 lambda. అంటే the wave covers x2 is equals to 5 lambda. ఇక్కడ నుంచి the wave covers x1 is equals to 5 lambda and they will meet at the center. అంటే x2 minus x1 is 0. 0 ఉంటే maximum. లేదా lambda, 2 lambda and all these things. Not minimum. It should be maximum. Okay, maximum. Correct. Maxima. ఎందుకంటే సార్ delta x is 0. Why? Because x1 is 5 pi, x2 is 5 pi, delta x 0 ఉంటే your maxima will be there. ఇప్పుడు in the same question రా, so this is my source S1, ఇదే నా source S2. If I say that the distance between the two sources is 11 lambda, the question is, as we go from S1 to S2, okay, let us see, S1 to S2, how many minima and how many maxima are seen? Adhe. Okay, it's a last level question. Maxima are seen. Let us see if you can try to. It's not visible, kida. Let me just shift it. We are moving from S1 to S2 now. So in between and in your way, how many minima you will see and how many maxima you will see? 5 minimas and 5 maximas. The answer is wrong. Okay, answer is wrong for sure. How, sir? Why wrong, sir? 5 minima, 5 maxima. Ante kada? Yes. 5 minima and 5 maxima. Should I directly do this question, or do you want me to take an easy question and explain Yura? Let us take the easy question and explain. Choose one. If this is your source S1, andariki, All of you, listen to me very carefully. This is chala important, okay? If you are understanding this, that means you will understand Young's double slit experiment very easily, okay? Chusko. If this is your distance, ide me source S1 and here is your source S2. Ide kada? Let us take an easy value. Easy value ante some small value. For example, let us say this distance is 3 times lambda, where lambda is the wavelength of the source. Yes. Chusko. So when you are at S1, hey, all of you try to understand. Now phase difference kavali. Yes. When you are at S1, when you are here only, when you are here, ante tell me about this wave first. First wave ante from S1 how much distance is first wave traveling Cheppandi. Enta distance travel chestundu. You are at S1. Source also at S1. Ante x1 value is 0. Ide kada? x1 is 0 Endukante you are here. Wave is here. x1 is 0. Ippudu when you are at S1, you are at S1 only. Ippudu S2 is coming from the wave 2. So second wave is coming from S2. How much distance it is traveling? So the value of x2 is nothing but 3 lambda. Ide kada? Yes. You understand, when you are at S1, the first wave is right with you, no distance traveling. First wave is here only, you are here only, 0. x1 value 0. Kani second wave kosam, it has to cover the entire distance, 3 lambda. Ante your delta x value is x2 minus x1. x2 minus x1 ante enti x2 value is 3 lambda. You're understanding? Yes. What about, sir, if the observer now moves a distance of lambda? Chuskondira. Sorry, the lambda distance has been covered. Try to understand. Okay? Not like this. I would not say like this. 1, 2. Ide lambda. 3 lambda is the total distance. Try to understand. Lambda is the total distance. So, ide lambda unte, if the observer is here, chuskondi, you have 2 different frames. Ante 2 different perspectives. Two different perspectives. What are the 2 different perspectives, sir? Your wave left, your first wave is traveling a distance. How much? Your first wave is traveling a distance of lambda. Ide kada? Yes. Lambda is the distance traveled by your first. What about the second wave? Cheppandi indiriki. What about the second wave? Your second wave is traveling a distance of 2 lambda. 2 lambda kada? Yes. Your second wave is traveling a distance of 2 lambda. Ante your x2 becomes 2 lambda and your x1 becomes lambda. Cheppandi, what is the path difference? Lambda kada? 2 lambda minus lambda ante lambda. Choose lambda is the path difference. At the same time, try to understand. Okay, try to understand. Try to understand, everybody. Correct. 2 lambda is the path difference. Correct. What about here? What about this point? What about at this point? Your path difference, Cheppandi. Your path difference. Can you tell me the value of path difference now? At this point. Okay, so here the path difference is 3 lambda. The wave has been traveling. Yes. If at all you check at this point, try to understand. Okay, andariki, try to understand. At this point, the path difference delta x equals to lambda. Hey, 3 lambda nunchi direct lambda. That means we are missing a point. One point will be here. Choose andariki. At this point, exactly at this point, ante ide 0.5 lambda. This is also 0.5 lambda. Yes. Try to understand, everybody. Try to understand. Okay. What's happening here is first wave is coming 0.5 lambda. Kani, the second wave is covering 2.5 lambda, 2.5 lambda, 2.5 lambda minus 0.5 lambda, ante delta x is equals to 2 lambda. Choose kodira. Hey, 3 lambda, 2 lambda, lambda, here 0. Understanding? Decreasing kada, decreasing. So exactly at the midpoint, the phase difference is 0, path difference. Now what? We are moving like that. Ante it will decrease. Decrease. Yes. Yes, choose ko. Initially, at this point, the path difference was 3 lambda. At this point, we are going right kada, 2 lambda. At this point, lambda. And exactly at the midpoint, this is the midpoint, okay? This is the midpoint. I'm sorry. Exactly at the midpoint, hey, exactly at the midpoint, delta x is 0. What do you think? 3, 2, 1, 0, minus 1, minus 2, minus 3. Are you understanding? Here it will be delta x should be equals to minus 1. Here delta x is equals to minus 2. Here delta x is equals to minus 3. Choose kodi. All are minus 1 ante minus lambda ra. Minus 2 lambda, minus 3 lambda. Cheppandi. How many integral points ra? 1, 2, 3, 4, 5, 6, 7 integral points are there. 7 integral points ante 7 maximas. 7 maximas. Okay, you want shortcut? Shortcut chapter. Choose kodi andariki. Jagrata. I'm telling you the shortcut, okay? How to do it? All the times you cannot trace the middle points kada. Do the same thing. Choose ko. If at all this is your point S1, shortcut choose kodi andariki. This is your S2 ra. Source S2. Choose ko. Let us say if the distance over here is somewhere around 4 lambda. Andariki. 4 lambda ante this is the distance kada. Yes. I am telling you direct shortcut ra. What to do now? What to do? Choose code. If you are standing here, andariki, first of all, write the value of delta x. Delta x formula should not change ra. X2 minus x1. Ide kada? This should be the value of delta x formula. Remember very carefully. Remember, delta x is x2 minus x1. Ippudu, when you are at s1 ra, andariki, cheppandi, what is the value of x1? Me kosam x1 ki value is 0. Kani x2 value cheppandi okasari. X2 value is complete distance traveled kada. Yes. For you, the x2 value ante distance covered by the second wave ra. Does not matter wherever you are. Wherever you are, x2 value ante distance covered by the second wave. Are you understanding? Yes. So your x2 value is completely 4 lambda ra. E point goes where you are here. Cheppandi okasari delta x value cheppandi. Delta x is nothing but x2 minus x1 kada. X2 value 4 lambda. x1 0 ante 4 lambda is your delta x. Idigo, this is the first condition ra. Ippudu directly go at this point. Once you have calculated path difference here, directly jump to this point ra. Cheppu, what is x2 value ra? X2 value ante distance covered by the second wave. Enta? 0. X1 value cheppandi. X1 value ante the distance covered by the first wave. 4 lambda. Ade kada? Yes. Cheppura. Path difference cheppandi. It is x2 minus x1. x2 is 0. x1 is minus 4 lambda. Ante minus 4 lambda is the path difference. Choose kondi. So now what you have to do is, at this point, andariki chudandi. At this point, your path difference is 4 lambda. At this point, your path difference is minus 4 lambda. Ippudu take the integral values and decrease it. Decrease kada? Yes. 4 lambda, 3 lambda, somewhere approximate. 2 lambda, then 0, then minus lambda, then minus 2 lambda, then minus 3 lambda, ide minus 4 lambda. How many maximas? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 maximas are there. What about minimas, sir? What about minimas? Good pettukondi. Minimas kosam, all of your minimas will be between the maximas ra. So here is my minima. Here is my minimum. 3, 4, between 5, 6, 7, 8. Ante you have 9 maximas and 8 minimas ra. Idi good pettukondi. It's a shortcut. Go at the extremes. It is giving you 4 lambda. It is giving you minus 4 lambda. Decrease. 4, 3, 2, 1, 0. Minus 1, minus 2, minus 3, minus 4. Yes. So 9 maximas and 8 minimas are there. This is how you do the work. Ardhamaindi? Correct. Let us take one more question, all of you, okay? Let us say this is your source S1 ra. Okay, this is your source S2. Separated by a distance d. Okay, this distance between the sources is small d. Distance is small d, correct. So I hope you understood, Ram. At least shortcut you understood, right? Choose distance is d, Ram. Okay, let me join the points also. This is the points. You are understanding? Let us say exactly from d by 2 distance. Try to understand. Okay, exactly from d by 2 distance, I have placed a screen. Screen and telusa. Screen. Choose code. In distance and capital D. This distance is small d by 2, and this distance is small d by 2. You are understanding these terminologies, all of you. So these are the two sources. Okay, d by 2, d by 2, d. My question is, what will you see at this point, Ra? At this point, the question is, will it be minimum or maximum? Exactly our point low, what will you see? Minimum ante telusa bright colors. Sorry, maximum. Maxima is for bright colors. Minimum ante dim. Dim ante darkness, Ra. Complete darkness. Correct. So you will see a maximum. Why, sir? Why maximum ante? This distance, ra, idigo, ide distance x1 kada, source s1 nunchi, and s2 nunchi distance is x2, ra. Choose x1 equals to x2. Why, sir? Because this Pythagoras, apply. This Pythagoras, apply. You will get same. You are understanding? Ante your x1 equals to x2, that means delta x equals to 0, that means your maxima is there. Ide kada? This is your maxima at the center point. As you keep on going up and down, can you tell me, Ra, where will be the first minima above it? If this is a minima, can you tell me this distance? If this is a minima, can you tell me the distance? Andariki. I'll give you a hint. Okay, I will give you a hint. Choose go. I will directly give you a hint, Ra. Let us say this distance is not d, okay? Let us say this distance is x. Andariki. A distance ante I am calling it x, okay? Distance is x. Try to understand. It's a very good question, okay? It's a very good question. Yes, because x1 is x2. What is delta x? If delta x is equals to x2 minus x1 kada, so rendu equal unte, it becomes 0, ra. If your delta x is 0, choose your formula is a net is equals to root of a1 square plus a2 square plus 2 a1 a2 cos phi. Cos phi ante cos 0. Cos 0 is 1. 1 unte this becomes maximum value. Leda, what did we say for maxima? Your delta x should be equals to n lambda. N ante integer. It should be 0, 1, 2, minus 1, minus 2. 0 put it, you get 0. So if your delta x is 0, you will get a maxima. Whenever you are telling that your delta x is 0, you will be having your maximum. Let me give you a hint, okay? Let me give you a hint. Your path difference. Meeku path difference kavali kada? Yes. Path difference delta x directly rasno. Choose path difference delta x is nothing but d into x divided by capital D. Idigo. This is the approximation. Leda, this is a hint from my side. Idi gurtu pettukondi. This is the biggest result that will be helpful for you. Choose delta x ante path difference, ra. It must be equals to d. D ante enti, ra? D ante distance between the sources. Ade kada? Distance between the sources. X ante how much above or below you are going. Capital D ante distance between the source line and the screen line. This is your screen kada? Yes. And what is it, ra? This is your source. Cheppandi. So delta x should be equals to n lambda kada? N lambda for first maxima. Hey, first maxima kosam. What is the formula for delta x, ra? Hey, for maxima it should be n into lambda kada? Yes. Yes. Delta x should be n lambda. Condition for maxima. Maxima condition, sir. You are forgetting, sir, or what, sir? We have discussed everything, Ray. How can you forget it, Ra? Where did it go? Same thing, Ra. Chusko. For your maxima, delta x should be n lambda, kada? For your maxima, delta x should be n lambda. Yes. And your path difference should be integral multiple of wavelength. Ante delta x ki formula enti ra idigo, this is the formula, d into x upon capital D. Ante d into x upon capital D is n lambda. Naku first maxima kavali kada, so put the value of n as 1 ra, lambda idigo. So from here x is equals to lambda into capital D upon small d. So your first maxima, not minima, I would not say minima, your first maxima will be at a distance x is equals to d into lambda divided by d. This is the distance. You are understanding? So exactly at the center maxima, if you go up by this distance, maxima, then 2d lambda by d maxima, 3d lambda by d maxima, 4d lambda by d maxima, kindaki kuda d lambda by d maxima, 2d lambda by d maxima, 3d lambda by d maxima, 4d lambda by d maxima. Understanding? If you have understood this, your Young's double slit experiment is over. Finished. Yes. Your Young's double slit experiment is completed. Same thing. Hey, you have two light sources. Akkada you have two slits. Two slits nunchi two light sources. They are passing. Screen is there. This is a formula. Completed. Your YDSE is this. Choose it. Understanding? Delta x ante path difference. Formula gurtupettukondi. Proofs and all are not going into because we don't have much time. Okay? I have to cover two more things. Gurtupettukondi. Young's double slit experiment ante entira. You have first slit. Okay, what you do now is you are actually throwing a stream of light. Stream of light ante wave of light kada. Yes, so these are the waves of lights. Chuskondi. So this is a light source. These are your light waves. Ide kada? Yes. What this source is doing is it is filtering the remaining lights. Ante it is allowing a single frequency light ra. Chuskondi. Okate source kada. Okate source unde. This is a single frequency. Single frequency unte. Now this light is passing through two different slits. Chuskondi. This slit S1, S2. Slit ante small blade cut ra. Cut in the paper. So what's happening here is every of light, it is actually passing through your S1 and your S2. If you choose whatever light is passing through your S2, it will create its own waveforms. Yes. Whatever light is passing through your S1, it will create its own wavefronts. Yes. Now what's happening is these two waves are interfering. These two waves are interfering. The same process. Distance capital D unte. This is your screen. The waves, they are interfering here also. And the waves, they are interfering here also. Are you understanding? And then the pattern is formed on the screen. Choose kondi. The pattern is formed on the screen. This is your screen kada? Yes. Kani exactly in the middle. Ide na source S1 kada? This is S2 ra. Exactly in the middle point. Choose kondi. Here you will see the first maximum. Dan tarvata d lambda upon d will be the second maximum. Central maxima, this is first maxima. This is the maxima. Value is 2d lambda upon d. And between them will be the minimus. Are you understanding? Yes. Yes, one screen will be there. All the times. Choose one. So, if this is my central axis, choose one. I am moving x distance here also. I am moving x distance here also. Try to understand. All of you. The biggest question is both the sources that are producing. Choose intensity. Gurtunda, intensity gurunchi we have talked. Intensity. What did we talk about intensity? If this intensity is I1, if this intensity is I2. Kani. Ee case lo your I1, I2 are same. Understand? Ee case lo your I1, I2 are same. Kabatti I am simply writing I. Here also I am writing I. Here also I am writing I. Here also I am writing I. Choose kondi right. Intensities are same. Ide kada? Yes. So the maximum intensity that will be formed. Cheppandi, what is the formula for net intensity, ra? What is the formula for net intensity? What's happening, ra? Yes, I net is equals to root of I1 plus I2 whole square. Ide kada? I1 ante root I ra, plus I2 again it is root I. Ide kada? Whole square. Ante 2 root I whole square. Ante 2 square is 4. I root I square is I. So this becomes my net intensity. 4I. Ante ee point lo your intensity will be 4I. Not only this point, every maximum point intensity will be 4I. Ekkada kuda intensity will be 4I. And for the minima kosam your intensity I becomes 0. Here also your intensity becomes 0. Ide kada? So when you observe the graph ante telusa, this are the values of x. Chuskondi ra, positive x ante I am moving upward on the screen. I am moving upwards. Yes, first minimum ante you can do the same experiments, ra. Your delta x should be equals to n minus half into lambda. Ide kada? They substitute the values now. Leda n plus half into lambda తీసుకో. n plus half into lambda. లేదంటే you can simply say, sir, small d into x upon d should be equals to lambda upon 2. ఇదిగో lambda upon 2 అంటే your x must be equals to d lambda divided by 2 into d. This is your first minimum. అంటే this distance. d lambda upon 2d. ఇదే కదా? Yes. Same principles. Now చూసుకోండి. Your x in the right side అంటే you are moving on the screen above. Negative x అంటే you are moving below. ఇదే కదా? Yes. ఇప్పుడు when you talk about the intensity రా, intensity చూసుకోండి, this was x equals to 0 కదా. For x is equals to 0 you have a maximum అంటే your intensity is 4I. ఇదిగో exactly here also your intensity is 4I. These are all the maxima points. Minimum points ikkada ra. Minimum points gurinchi cheppalante these are your minimum points between the maximas. Ade this and this. Ante your graph will look something like this. Try to understand, okay, everybody. This is your graph, ra. Not like this actually. So this should be your graph. It is going and decreasing and increasing and decreasing, something like this. Okay, here also going and decreasing and increasing and decreasing. This is a graph. Okay, this is a graph for your Young's double slit experiment. Yes, for minima intensity will become 0. చూసుకోండి, this is your central maxima ra. Okay, x is equals to 0 kada. Yes, దాని తర్వాత your maxima will be x equals to d lambda upon d. Your minima will be at x is equals to d lambda divided by 2d. ఇక్కడ చూడండి, here your second lambda will be 2d lambda upon d. This point will be d lambda upon 3d. Then add these two, okay? Extra distance. I think it should be 3 by 2. These are the distances for your maxima and minimum. అర్థమైంది అందరికి? Yes. Try to understand, ra. Okay? You want to explain once again? Okay, let me explain once again. I will explain, don't worry, okay? Screen kada? Yes. ఇప్పుడు I'm not taking all those waves and all patterns ra. చూసుకో, నా దగ్గర 2 light sources are there. ఇదే నా source S1. This is my source S2. అంతే కదా? For sure. Okay. Yeah, that's what I'm telling to you. The graph looks something like this. Ante maximum points ante these are the maximum points. This. These points ante All these points over here are this. These are the maximum points. On this maximum point, choose for this is the screen kada. So maximum unte white color is maximum, white color is maximum, white color is maximum, white color is maximum, white color is maximum. What about minimum point? Red color. Let us say red color is your minimum. Ide minimum. This is minimum. And this is minimum. Ra. So your intensity changes gradually. Not exactly dark and bright patterns will be there. Okay. These are not. Okay. Just whatever you want to write it. Try to understand. Yes, so these are your fringes. Okay, Young's double slit experiment. Try to understand. Now we will have to see about the different cases of your YDSE. Young's double slit experiment. Done? Not done. Hey, try to understand everybody. Okay. Next case lo, what will happen is, let us change the angle. Change the angle and tira. Next case lo, we will talk about the fringe width. Okay. Ippudu we will be talking about your oh. Hey. I don't know, Ra, who are you? But don't spam, okay? Don't spam. So, okay, fine. Hi. Hello. Anyways, Ra, చూసుకోండి. So, basically try to understand that the terminology goes something like this. చూసుకోండి. If you have two light sources, అంటే ఇదే మీ first light source S1. This is the second light source S2. ఇదే కదా S. Now, what we are doing is we are going to observe for the minima and maxima. చూసుకోండి, the fringes will look something like this. Rather, I should take a screen something like this. Chuskondi andariki. So your patterns will look something like this. Okay, try to understand andariki. So this is your bright pattern. Then you will get a dark, then bright, then dark, then bright, then dark, then bright, then dark, bright, dark, bright, dark, bright, dark, something like this. So this is the pattern you will be observing. Ide kada? Hey, hey, yeah. Hey, brother, I don't know who you are, but I love you, okay? Don't worry. Okay, చూసుకో. Hey, try to understand, ra. This is your first maxima, kada? Yes, ide me first maximum. దాని తర్వాత let us talk about your, should not be first your maxima. It is a central maxima. Hey, central maxima. దాని తర్వాత it is your first maxima. This is your second maxima, and so on and so forth. You are understanding? Now I am talking about the fringe width. Fringe width. Okay, I don't know. Let us say this is a fringe width, ra. What is the fringe width, sir? Fringe width is nothing but, try to understand, okay? Try to understand. How should I explain you, ra? Chuskondi re. Basically, can I say that this distance is nothing but your d lambda by d only, ra. Idigo. This is your fringe width only. You're understanding? You're understanding? Okay? This is your fringe width. How should I explain it? Your fringe width is nothing but distance between two minima kada? Yes, చూసుకోండి. ఇదే మీ ఫస్ట్ మినిమా, this is your second minima. అంటే distance for your minima 2 minus distance for your లేదా minima 1 should give you the fringe width. You do it, you will get the same answer. Okay, ఇదే మీ fringe width is this. Are you able to get it? Right. ఇప్పుడు let us see something about, hey, I told you, don't spam, okay? Don't spam, because we do have some other works also. Anyways, now what we'll do is, your class is supposed to be till 3:30. So in half an hour low, I have to complete your YDSE, your diffraction of light, your polarization. Not possible. Let me focus, ra. Let me focus. Don't distract me, okay? Chuskondi. Now, what happens is, if you are spamming like that, how do you think I will prepare, ra? Huh? So this is my screen. Okay? Chuskondi andariki. This is your screen, ra. These are the two slits, okay? Ide your first slit, your second slit. Andariki chuskondi. This is your second slit. Ide kada? Ippudu what you will be doing is, when you are passing the straight lines exactly horizontal ante these are your straight lines ra. Andariki chuskondi. Are you understanding? Yes. These are your lines of light. ఏమైతుంది అంటే exactly at the central position ante ide. You will get the maxima over here ra. Understanding? Kani if you tilt this light, and if you change the angle now, ippudu when you are throwing your light something like this, chuskondi. If these are your lights, are you understanding? At some angle theta ra, chuskondi. This angle ante, let us say this is theta. You have tilted it a little. Mari, what happens with this position of maxima, ra? Do you think it will stay the same? Do you think it will stay the same? Do you think it will stay the same? No ra. Ledanti. What happens is this maxima gets shifted a little up. Understanding? Yes. So this maxima will be shifted a little up. Let us say x distance has been shifted. So what will you do now is, in this case, cheppandi. What you will do is, you will simply say, sir, x into d upon d, and the first maxima kada should be equals to d into sin theta. Adigo. This is the formula. So your x is equals to d sin theta. Am I doing correct? Yes, so this is the formula. D sin theta, your dd will get cancelled. Carry on. Let's see the class. Thank you so much. Thank you so much for your relief, Ra. Okay. Hey, Chapandi Ra. So, you can simply say your x value is d sin theta multiplied by capital D upon small d. dd gone. So, x is equals to d sin theta. And your first maxima will be shifted by this much distance. Are you able to understand? Yes. Yes. Okay. Yes. So this is the position of your first maximum. Blue. I have 2-3 more cases, but I don't know if I should discuss or not because we don't have much time left. Choose. If Young's double slit experiment, if YDSE setup, okay, if YDSE setup is formulas మాత్రమే గుర్తుపెట్టుకోండిరా, okay, proofs and all I'm not giving you because not required. అంటే your entire system, your slits, your light, your screen has been kept. Yes. If everything has been kept in a transparent medium, for example, water లేదా glass, okay, let us say the refractive index of water is mu. So if you are doing the experiment in air, I don't know, I don't care about the setup, నాకు only screen కావాలి రా. చూసుకోండి స్క్రీన్ లో what patterns are there అంటే this was your maxima, ఇదే కదా, this was your maxima. Fringe width చూసుకోండి. Fringe width అంటే తెలుసా, if you are dipping the same thing, if you are dipping the entire setup in a transparent medium అంటే ఏంటి తెలుసా, if this is your transparent medium, refractive index mu రా, ఇదిగో refractive index mu ఉంటే this is your screen, everything is placed in a transparent medium. ఇప్పుడు ఏమైతుంది అంటే the fringe width రా, what is the fringe width? I told you the fringe width, చూసుకోండి, the fringe width is equals to d lambda upon d kada. It will get shrink because of the refraction of light. Understand? Good petko. It will get shrink ra. So this is your fringe width, all of you. This is your fringe width. Chuskondi. Shrink aindi kada? Yes. So this is the shrinked fringe width. What is the value of fringe width ra? In case lo, your fringe width equals to చెప్పండి d into lambda upon mu times d. అది mu times d. ఇదిగో. Try to understand. Here fringe width f. Hey, if the f is the fringe width here, this will be f dash is equals to f upon mu. ఇదిగో. This is the relationship. And the fringe width will be decreased by this factor. Okay? So keep it in mind, whatever it is. Choose good. Now, what do we want? We want to apply the correct. Yes, it decreases by mu times. Okay, the fringe width decreases by mu times. చూడండి. Now let us try to introduce a glass slab ra, okay. Yes, let us increase the speed ra. So ide na first speed, a slit, this is my second slit. Exactly at the junction of the first slit I am putting a transparent glass slab. Telsa slab, this is a slab ra, glass slab. What will happen? Thickness is T, refractive index is mu ra. ఇప్పుడు due to this glass slab, what happens is, చెప్పండి అందరికి, due to this glass slab, the first maxima position gets affected ra. చూసుకోండి, your initial maxima is here. ఇదే కదా? Yes. What's happening now is, due to this glass slab, what's happening ra? This light that's coming over here, it has to cover more distance. ఎందుకు more distance, sir? Because medium has changed. Speed decreases. Time remains the same. Until distance will increase. That means x2 value has increased. x2 values has increased. So to balance it, we will have to shift this maxima a little upwards. చూసుకోండి, ఇదే, if this is your original maxima, MO ra, MO, and ఇదే మీ final maxima, చూసుకోండి, after shifting ra, this distance నాకు కావాలి, ఈ distance కావాలి రా. Distance ఏంటంటే, try to understand. In geometrical optics, we have seen a formula. What formula ra? చెప్పు. The shift due to a thick slab. The shift due to a thick slab is given as T into mu minus 1. ఇదిగో, T అంటే thickness, mu అంటే refractive index, and all this. This is a shift, and this extra distance has to be covered. That means it must be dx divided by small d. ఇదే కదా? Hey, small dx by capital D ra. Small dx upon capital D. So ఇక్కడ నుంచి simply say, sir, your x is equals to T into d into mu minus 1 divided by d. ఇదిగో, this is a distance by which your maximum will be shifted. అంతే కదా? Done. I think all the cases are completed. ఇప్పుడు we will talk about your diffraction of light. చూసుకోండి రా, diffraction. You have diffraction of light. Hey, don't worry ra, we can take it at 4 till 4 p.m. also, okay? Not 3:30. We can take it till 4 p.m. also. No hurries. Hey, diffraction అంటే ఏంటిరా? You try to understand, okay? For a diffraction purpose, ఈ diffraction ని అర్థం చేయడానికి we will take a single slit. Okay, single slit. ఒక single slit నుంచి we will analyze the behavior of light. చూసుకోండి all of you. When your light is passing through this single slit, చూసుకో, this is your light particles కదా? Or let me little zoom it up, okay? Not like this. These are the light particles ra, చూసుకోండి. They are coming in a straight line ra. Hey, చూసుకోండి అందరికి. They are coming in a straight line. కానీ do you remember Huygens theory ra? Huygens theory అంటే ఏంటి ra? These, it will now create ripples అంటే తెలుసా? These are the ripples. Okay, these are the ripples created by the Are you understanding? These are the ripples created by the light rays. Kani, I want you to focus. Ra. This is my straight line kada? Yes. This is your straight line. And the ripples will be majorly in this straight line only. They will be traveling majorly in this straight line. Kani, when you observe this, చూసుకోండి అందరికి జాగ్రత్తగా. These are the points, okay? These are the points. These are the extreme points ra. How should I let you know? చూసుకోండి. You are understanding? These are the ripples. Kani, when you analyze, చూసుకోండి, your straight line is like this kada? Your straight line is like this. అంటే all your ripples must go through this straight line only. Kani, you observe these points ra, andariki, you observe these points. This. What they do is they try to create their own wavefronts kada? Yes, because every secondary source acts as a source itself. Every point on the wavefront acts as a secondary wave source ra. So this point also create its own waveforms. Ante these waveforms are scattering. Chuskondi. They are not in the straight lines. They are scattered a little. Understanding? Ikkada kuda the same thing. You observe these points ra. these points, what they do is they create their own waveforms. Chuskondi. Ante whatever the expectation of light was, some light is also getting diffracted kada. Chuskondi. These light particles, they are getting diffracted. Kani your major light is here only ra. Your major light and the highest intensity will be between these two only. But at the same time, you have small intensities ra. You have small intensities that scatter. This scattering is known as, Leda, this diffraction is known as the diffraction of light. Try to understand. Okay, try to understand. Not too much to tell. Okay, not too much to tell. Sorry. So this diffraction is usually studied in two ways, ra. Okay, rendu waves unnai. Number one, Fresnel study, Leda, Fresnel method. Number one, Chapandi. First is Fresnel method, Leda, Fresnel diffraction. Second one is, do you remember? I think completely the chat section has lost the importance. Don't you think it's correct? Correct. Very good. Very good. Very good. Fraunhofer. Very good. Very good. The second type is diffraction. And these are the methods to study the diffraction. If these are your slits, okay, this is your slit, most of the light is passing in a straight line. There are some light waves, some particles, some waveforms of the light that diffract. You are understanding? When you are studying these diffracted waveforms at a given distance, the given distance until the finite distance is there, the distance is finite. So if you are studying this diffraction at a finite distance, that would be considered under Fresnel method. Kani, it is a complicated one, okay? It's a little complicated. Kabatti, our syllabus only demands of Fraunhofer diffraction. Fraunhofer diffraction and entira. Yes, you are there, but not everybody. Hi. Fraunhofer diffraction, we will analyze the pattern of diffraction. In Fraunhofer diffraction, we will be analyzing the pattern at infinite distance. And your screen will be at infinity. Technically speaking, technically. Not really. Hypothetically, it's not. It's only possible hypothetically. Not practically. So, we have to study the lights at infinity. But can we go to infinity? We have a smart trick. We'll do one thing. We'll use a lens, convex lens. What does it do, sir? It converges. Converges ante the light rays or the image. These are the light rays that meet at infinity. Yes. These are the light rays that are meeting at infinity. Kani, I want to see it. I don't have time to go to infinity. You simply shift all this and you pass this through a lens. Whatever image this information, whatever information these light rays are having, in light rays and information, whatever the light rays have been carrying will fall on your eyes and see the image. Same information that will usually be formed on infinity. With the help of this convex lens, we will get all that information on the focal point. Chudandi. This is the image. Yes. Ante these light rays that are meeting on infinity now are meeting on a single point. And that point is at a focal distance. Ante telusa, you have used a very smart trick. If you don't use this lens, these line rays will meet on infinity only. Ante you will have to go to infinity. Impossible. Understanding? This is the biggest smart way that we are using. Try to understand. Let us see, okay? Let us see. Now what we'll be analyzing is, hey, what should I say now? How should I represent it? You have a diffraction from a single light kada. Yes. So let us imagine it is a slit. Okay, andariki this is a slit kada, this is a slit, and ఈ slit lonchi we are passing some lines ra, చూసుకోండి. Are you understanding? Single slit ra, ఒకటే slit ఉంటుంది. Here we are not talking about double slit experiment, it's a single slit. కానీ we'll have to analyze about the fringes kada, ante the diffraction of light ra, some light is passing in the diffracted form also. కానీ చూసుకోండి, if this is your screen ra, hey, we are doing Fraunhofer diffraction kada. So Fraunhofer diffraction lo the image is formed at infinity. Not possible to see. మరి ఏం చేయాలి సార్? Put a lens. అదే put a lens. You are putting a lens. Infinity image will be brought close. ఈ లెన్స్ నుంచి f distance లో ఒక స్క్రీన్ పెట్టండి. అదే f అంటే ఫోకల్ లెంత్ ఆఫ్ దిస్ లెన్స్ రా. You are understanding? Yes, single slit. So ఎప్పుడు when I see the pattern ra, the pattern was something like this. చూసుకోండి, when I observed the pattern came out to be something like this. Ante in this region only, in this region over here, there was a very bright fringe, very bright fringe. Okay, chala bright fringe ra, exactly in this area చూసుకోండి. దాని తర్వాత there were bright patterns also ra. I'm not telling there are not, కానీ sometimes there was a dark fringe also. Here also dark fringe ra, చూడండి, dark fringe. Hey, dark fringe tarvata immediately you have a bright fringe. Here, understanding? Here also you have a bright fringe. Kani width chudandi, width. Then again you have a dark fringe. Hey, idhe mi dark fringe ra. This is your dark fringe ra, andariki. As I am going away, dark fringe width increases, bright fringe width decreases ra. I'm not even able to tell the words, you know. Chudandi. Hey, this is the width. Ide. Understanding? మళ్ళీ ఒకసారి డార్క్ ఫ్రింజ్ రా, డార్క్ ఫ్రింజ్. దిస్ ఇస్ ద డార్క్ ఫ్రింజ్ రా, దిస్ ఇస్ ద డార్క్ ఫ్రింజ్ రా. ఓకే, ద ప్యాటర్న్ ఇస్ సంథింగ్ లైక్ YDSE ఓన్లీ. ఇట్ ఇస్ YDSE ఓన్లీ, కానీ విడ్త్స్ ఆర్ డిక్రీజింగ్. ఇంటెన్సిటీ విడ్త్ డిక్రీజింగ్. ఎస్, యూ మస్ట్ హ్యావ్ ద లెన్స్ రా, లేదంటే యూ విల్ నాట్ బి ఏబుల్ టు సీ ఇట్. Okay, you will not be able to see it because the image will form at infinity, technically speaking ra. Chudandi, so ante the intensity keeps on decreasing. You are able to understand? Yes, the ఇప్పుడు గ్రాఫ్ గురించి చెప్పాలంటే you try to understand. Okay, the graph looks something like this ra. We talked about your YDSE also kada. Yes, the graph ante central maxima lo your intensity is I naught only. I naught ante I only ra, whatever intensity you are throwing it with. Okay, if your light intensity is I, this intensity will be I naught. Ade dan tarvata these will keep on decreasing, right? It will not become 4I. You are understanding? So it is I, then it will decrease, then it will slightly increase, then it will decrease, then it will slightly increase, then it will decrease, then slightly increase, all these things. It will keep on going like this ra. Here also same thing. Hey, decrease, then it will slightly increase, then decrease, then slightly increase, then decrease, then slightly so like. This is a pattern ra, గుర్తుపెట్టుకోండి. ఓకే, దిస్ ఇస్ అ ప్యాటర్న్. మరి సార్, ఐ హ్యావ్ టు టాక్ అబౌట్ ఫ్రింజ్ విడ్త్ కదా. ఎస్, ఏ యూ వాంట్ టు టాక్ అబౌట్ ఇంటెన్సిటీ రా. ఇంటెన్సిటీ అంటే ఒక జనరల్ పాయింట్ లో మీకు ఇంటెన్సిటీ చూడాలంటే లెట్ us say దిస్ ఇస్ ద పాయింట్ రా. మళ్ళీ ఏం చేయాలి సార్? యూ డ్రా ద లైన్, డైరెక్ట్లీ డ్రా చేసుకోండి సార్. వాట్ ఎవర్ యాంగిల్ దిస్ లైన్ ఈస్ మేకింగ్, theta. సో ఇంటెన్సిటీ అట్ అన్ యాంగిల్ theta is given as, చెప్పండి, your intensity at an angle theta is given as I naught అంటే this original intensity. Okay, I naught into sin square beta divided by beta square. గుర్తుపెట్టుకోండి రా, this is something. Okay, this is something. Formula పెట్టండి, only formula you remember. Okay, only formula you remember. చూసుకో, బీటా అంటే ఏంటి సార్? Here is theta. What is beta sir? Beta has a special formula. Beta అంటే pi b sin theta. Yes, pi b sin theta divided by, చెప్పండి, lambda. Sir, what is b? What is sin theta? Theta మీకు, this is theta. What is b sir? B is the width of the fringe. B is thickness లేదా width of the fringe రా, lambda is the wavelength of the light. ఇది గుర్తుపెట్టుకో చాలా. ఓకే, these formulas are more than sufficient రా అందరికి. Try to understand. Okay, so let me write one more equation, all of you. What is the equation రా? Your equation is intensity at an angle of theta is given as I naught into formula గుర్తుపెట్టుకోండి రా, sin square beta divided by beta square. ఇదే కదా. What is the value of beta, sir? Beta is pi b sin theta divided by lambda. Okay, pi b sin theta divided by lambda. Lambda అంటే wavelength రా, don't get confused. ఇప్పుడు now let us talk about both the equations. Okay, both the conditions రా, both the conditions చెప్పండి. For minima ఇదే కదా, minima చెప్పురా. మినిమా కోసం your theta has some conditions. అంటే sin theta should be 0 కదా, మినిమా కోసం beta should be 0 రా, then and only then your intensity will become 0. మినిమా కోసం your sin theta should equals to 0. ఎందుకు sin theta sir? Sin theta 0 అంటే beta 0 అంటే ఈ ఫార్ములాలో this becomes minimum, maximum sir, minimum sir. I think it's for maximum ra, not minimum. Okay, sin 90, sin 180, all of them they are maximum until the limits become sin square x upon x. Yes, maximum only ra, because if you see it, okay, I would say it should be minimum only, not maximum. Chuskondi, it must be minimum. Endukante if you want to talk about the maximum value, you might have to differentiate it. Yes, maximum gurinchi cheppalante, for maxima chuskondi, for maxima your intensity di theta divided by your d of beta should be equals to 0. Understanding? When you differentiate it, you get beta square into 2 times of sin beta multiplied by cos beta. U dash v completed kada, u dash v minus u into v dash ante sin square beta multiplied by 2 beta should be equals to 0 ra. Ante your beta gone, 1 sin beta gone, 2 kuda gone. You are left with beta into cos theta minus beta into cos beta minus sin beta should be equals to 0 ra. Ante sin beta by cos beta ante tan beta, so beta should be equals to tan beta. This is a condition for your maxima ra, and for your minima your theta should be equals to m pi. Idigo, these are your conditions. Okay, the maxima kosam beta should be equals to tan beta, minima kosam your theta should be equals to m pi. Chuskondi. Okay, right, chalu ra, this is more than sufficient I believe. Okay, more than sufficient. Ippudu how much time remaining? 10 minutes. I think it will be completed ra, completed. Chuskondi. Let us talk about your polarization of light ra. Okay, chudandi, we are talking about your polarization of light. Polarization of light ante enti sir? You try to understand. Okay, if you have a light ante enti ra? EM waves ante electric field, magnetic field oscillating perpendicular to each other kada. These are your components of electromagnetic wave ra. Chudandi andariki. Now what happens is your light particles whatever they are there ra, andariki chudandi, they have the electric field. Ante different particles have different electric fields and different magnetic fields. Chuskondi. So this, how should I explain it? Okay. Have you seen that your mobile screens, mobile screens? I think there are some Instagram reels viral. Our reels, what they do is they take out the upper layer of the mobile phone. Ante screen lonchi upper layer, they take it out. They make a spectacle out of it, and they see your phone. Ante enti, what happens is when you see it open, you will see only a white screen. Kani, okasari, you are wearing that spectacles, and you will see exactly everything on the phone. What's happening over there is you try to understand. Your electric component is responsible for your vision kada. Electric component of the EM wave ante light ra. Light lo you have rendu components. First is your magnetic component, second is your electric component. What's happening is your electric component is responsible for your what should I say? Sense of vision. Okay, sense of vision. So what is happening is you have your electric field oscillating in multiple directions. Now what do is you take a polarizer. Andarki chudandi. Ee polarizer lo you have some axis of polarization. Okay, you have some axis of polarization. What happens is as soon as these light particles they are passing through this polarizer emaitidi ante the polarizer filters out the remaining axis of electric field. Ante it will just make the electric field oscillate in a single direction. Are you understanding this? Ante the polarizer simply removes the other oscillations of the electric component and only lets a single type of oscillation pass through it. You understand? Filterization process, rather. Okay? Yes. Filterization process. Indra, am I audible? Am I audible, all of you? Yes. So, you do the polarization from different ways. Number one is your refraction. Refraction at intira. That means, let us imagine this is your plane. Kada? These are your electric fields. Okay? They are hitting something like this. Try to understand that. No, how should I explain? As soon as the light ray is getting refracted ante, refracted ante sir, refracted ante, it is bending towards the normal. Here, the refracted light ray is not having that much of oscillations, and it is partially polarized. Your light ray is partially polarized. Ante it is a partially polarized light. And when you talk about your reflection, in your reflection, all the light gets completely polarized. Okay? Your reflection, all the light gets completely polarized. Yes, completely polarized in your reflection. In your refraction, you have partially polarized. Okay? So if it's a reflection surface, light rays coming, hitting, going like this. Okay? It is unpolarized light. These arrows and the electric field is oscillating in these directions. Okay? Sometimes like this, sometimes like this. Try to understand. Okay? Yes. Brewster's law. Yes, Brewster angle is there. So ఒక్కసారి your reflection has been completed అంటే complete polarized lights will be passing after the reflection. You understand? Yes. Reflection lo you have one more case, ra. Reflection lo you have one more case. One more case ante enti ra? What is going on in chat section? Yes, completely polarized in reflection. Your Brewster law states that, చూసుకోండి రా, if you hit the line at a certain angle ante, if you are hitting that line at some specific angle with respect to the normal only, right, in refraction, చూసుకోండి ఇదే, this is your incident light ra. Okay, let us say this angle is theta. If this angle is a spatial angle ante enti ra? What is this spatial angle? Do you know? Do you know the condition? What is the spatial value of this angle theta? So once you have thrown this light at a spatial angle ante, instead of partial polarization ra, చూసుకోండి, instead of partial polarization you have complete polarization of refraction. Ante there will also be some reflection kada. Yes. Kani it's a special angle ra. The angle we call it as Brewster angle, okay? Remaining all is the theoretical topics, right? Sure. So this is known as your Brewster's angle, this is your Brewster's law, okay? Dan tarvata completed. I do have a meet actually. Tell me, ఏదైనా doubts ఉంటే చెప్పండి, else we'll conclude our chapter here itself ra. Because I have completed all the major topics, okay? There are some topics left, not saying complete chapter has been there, కానీ very small topics ra, no chance, almost very negligible chance to ask in the exams. అంటే ఏంటి రా, if you have diffraction due to a slit, కానీ circular slit ఉంటే the diffraction patterns will be forming in a rings, that format, okay, and all those things. చెప్పండి. Yes, water loan, for water your Brewster angle is 53 degrees and remaining, okay, sir. Okay, so if you don't have any doubt, can we end up this session? Andariki cheppandi okkasa. Right, bye everyone, bye.